real walls are lost the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe is all view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a rule. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up the ante, making power for days. Don't listen to a word that the straight dope says. Mike building batteries to power a ship. Victor comes in talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tone trumpet prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope big old man Bills.
Hello everybody, welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
Happy Juneteenth, motherfuckers!
Juneteenth. Oh, love it. Oh, man, we're going to be talking some RF plasma today, bro. Oh, I love that stuff. What's going on, Joe? Out there working hard?
Yeah, man, everything's doing good. Hope everybody's good out there. Right? We're coming up on the first day of summer, so something always nice. Winter for the down under people. That sucks for you, but sure it's probably like winter in California.
Oh, it's hot. It's already hot.
Yeah. Winter by me, where it's like 15 below and such, you know.
Shout out Jarvis, man, coming in hot, brother. Your super sticker right there, $3, brother. Brett, right on.
Appreciate that.
We hit 10K, man. Yeah, we're getting rolling, man. It's still climbing.
That's right. So yeah, we got some cool stuff to look at today, don't we?
Oh, absolutely. Give me 1 second. I'm pulling it up for you.
Yeah, so we haven't done one of these in a while because, you know, it's like, you know, the experiments have been a little on the slow side, but Sean, he's hard at work and he puts the stuff up on the channel for shorts and everything. And, you know, we haven't really spent too much time talking about it because this is not typical RAV stuff, but this is, you know, this is high-end plasma physics, so this is good stuff.
Oh, dude, this thing right here, the way it builds out, in the pictures he sent, it reminds me of a harp in the fact that it's like different strings pulling in different frequencies, you know what I mean? Each layered into it, and there's so many of them.
Right. So yeah, let's play it, and then we'll talk about how this happens a little bit, because seeing is understanding in this case. It does.
So we'll slow it down. I just want to show it through one time. Yeah, it's wicked, man, how it does that. So it goes from an RF, and then you can see as soon as it hits that little piece of glass, I believe it is, now we're switching over to like a voltage multiplier, because it's pulling capacitance into it. So you can clearly see the energy changes.
Mm-hmm.
I think that's so cool. Look at that. See? Total different.
But why does the energy change? So that's kind of the interesting thing about it, right? It's the energy changes because as the connection between the anode and the cathode continues, that intermedium where it's actually arcing over, okay, is a ratio meld of both the anode energy and the cathode energy. And what ends up happening is you have frequency banding that occurs based on the offset differentials of the anode and the cathode. And the way that all ends up banding out ends up being cymatic in its exchange. So it ends up breaking and banding out in different geometries and relationships, but it makes like strands.
Mm-hmm.
Yeah.
Well, this is also, like when we talk about testing, this is more of a linear test than it is a compression test. Mm-hmm. So when you see it come out like this, you see the nice banding on it. Just think about it this way: had that centerpiece be replaced with a ball, this stuff goes around it and becomes spheres. So now it's spheres at a certain distance from each other instead of just lines. It's so interesting when you add geometry to something like this because it changes how it does compression in it. Right now, it gets to the little tube back there and creates some compression in it. which is able to switch it and create a slosh. But when you do it in 360 degrees, it creates a compression, and then it definitely gives you the slosh.
So dead on. And and the other thing with it too is the magnetic components. Okay, so whenever we we had heard Dr. Weeping you say, right, like everything is magnetism, and like I know that kind of, it's like yes and no, like magnetism, magnetic components, right? But the way that it builds out in its geometries, right, is that magnetism too has different dimensions of its field structure. And
Mhm.
when what you end up seeing, like, is this has a major magnetic component, but it's dimensionally inferior, okay, to um other plasma experiments like RAV, for instance, right, which has multi-vector magnetism, multi magnetic components coming together to then form a whole system of a higher geometric order. And that's when you start to get the compression.
Mhm.
That's why it goes parabolic, right? So that's actually when it goes parabolic, that's when you get this switch, in the dimensionality of the magnetism's field geometry.
Mhm. It's like when people talk about Tesla coils and they go to a scalar coil versus a regular coil. Basically, they just put a round ball at the top, and it builds out differently. You know what I mean? Like
Mhm.
this would be like a standard Tesla coil. I would wish every Tesla coil looked like this, but you know what I mean? I would just say that's what it is, and then you go to the other one, and then on the sphere it builds out from it. But it changes the actual distance that things can go out as well. When you get past this, then you start to really push the distance. This right here,
Absolutely
it
right.
stops at 5 feet. Yeah.
Yeah, this is directed. So what you end up with is diffuse leakage field sort of thing. There's no defined field boundary on that axis, right? So you don't have that field axis that builds out like the bubble at that point
Yeah.
to push it out.
Dude, these things are incredible right here.
Oh yeah,
So you see the pictures on this, man. It's absolutely unreal.
it really is. And I mean, you can see exactly what all those bands. It's all self-structuring behavior. It's plasma and self-structuring behavior.
Well, that's funny because we looked at the RAV and we said, well, why is it self-structuring? And then when you see this, you clearly see the distance between each one and the structure's already created in it.
Hmm. It is, and if you add the extra dimension to it, where it's going to go parabolic and start to compress, what you would notice is that all your light bands and your dark bands, they would actually compress and separate. Okay, so
Mhm.
that's where you get your layering from. Your
Oh,
layering
yeah.
comes from those bands.
It's as we see each one is frequency, it's sound in between.
Mhm.
If you ever looked at the sound acoustic test, that's what you see, the dark bands in there with the colored ones. And that's exactly what we're seeing here. So I don't think there's any difference, Joe.
I absolutely agree, and there's definitely sound in between. In fact, the entire thing is sound. In fact, everything is sound. That annoys people, but the word was first, man.
I mean, look, I agree with you, Joe. I think there's certain parameters that are in everything. You know what I mean? And sound's one of them. And you can never take it out either.
Nope.
I want to thank Darren here, Five Old Men's Build membership. Darren, you're awesome, brother.
Yeah, sweet dude.
Yeah, man. This stuff is beautiful. So the crazy thing is because we don't really think about this, and when you start thinking about it, like, okay, we have this coming out in different frequencies, it's layering properly. We know something like this is in resonance. Then we go to the other one, like a round shape, and then we know it goes out in spheres and everything. People are wondering in physics if this is the way things build out. But then when you start looking at the testing, you go, well, yeah, it has to build out that way because I get a lot of questions in when you start building fields and stuff and you want to build a field bubble. Why would it build out in layers? And well, it's a simple thing right here. If you're following frequencies, then it's going to build out in layers like that. So if you took away every third one, those are the ones it builds out in, right? So you get that harmonic right there, and it comes out pretty. Yeah, it comes out really clear through the whole thing, and they wonder why it does it. It's because it's natural to it.
It is, and and in this picture, and this is a wonderful example of it. You see the banding clearly to the side, but you also see that it has a central axis point.
Yes.
And it's all helical relative to each other. Okay, but at the same exact time, it's the outer boundaries, and this makes sense. And this is why there's so much deviation in the Rav's outer shell, right? With frequency, is because it just winds a lot tighter in the middle, whereas the outside is like looser, and that means that it's harmonically balanced in resonance, as opposed to it just being pure resonance, right? So it's not running at the same frequency. It can't, because the diameters are different.
Yeah. Shout out Jarvis real quick, man. Vortex. Thank you very much, brother. Appreciate it.
Right on, dude. Twice in a day, man. We much appreciate it. Love you too.
So yeah, I think what we're hitting on right here is that we have a vortex. I mean, that's what I think you were just saying, right? We have layered vortex.
It's there, and it has a rotational bias to it too. So when you watch it full speed, you do see that it has a rotational bias. In this particular case, if I'm not mistaken, I think it was a counterclockwise rotational bias. But
yeah, you could be right. It looks like that.
Yeah, it looks like a counterclockwise rotational bias, but it doesn't have the velocity yet to come together. And yeah, that once again appears to be. I mean, actually, that looks like a clockwise bias to me.
Yeah, you kind of see the little loop at the top where it starts to break free, and you see that's beautiful, man. It has that purple look, and it's like a faint purple, and then it starts the lines on the side of the white that comes down. Looks like ribs coming off.
Yeah,
man, that's special. And then you see on the right side, it breaks down for those 4, I think it is, and comes across. So it starts meshing it. That's cool.
You know what's cool too is like a lot of these, a lot of this, even though it's mixed of the anode and the cathode through that exchange, these are still anode biased arcs at the end of the day, right? But if you look at where it contacts onto the cathode surface, okay, you'll see that it has more energy at those particular points. And that's because those are actually on a cathode bias. That's the same as the lightning tendril, where it's pulling that higher density potential right out of the cathode and condensing it in that point for the connection to be made. So that's something interesting, when you look at the little balls where it meets that cathode, that's what you're seeing, and it's sustained. Lightning happens so fast that you can't appreciate that it pulls that energy out of the surface in its diffuse state.
Well, when you look at this, it almost looks like a shell. You know what I mean? It's got the twist, it's got the turn in it. You know what I mean? It kind of, not all the way there, but it's getting there.
Yep.
Yeah, you see at the very bottom there, you were talking about the little balls. This one has quite a few at the bottom.
Yep. That's really cool. That's like making like an organic form. It looks organic, it looks like a body, it looks like a leaf, it looks like, there's a lot of stuff that naturally arranges itself that way.
Yeah, this is kind of that harp look I was looking at. You see the twist in it, and then on the side, you got the nice long layers.
Well, if you look all the way at the anode to the top, okay, you could see that it's helical, okay, and then as soon as that spin starts, it's winding real tight. So actually, you have a lot of rotational bias from the arc once that magnetic component's kicking in. You see that?
Uh-huh. Well, I bet you if you put a magnet under it, it would vortex a lot heavier.
Yeah. I mean, it's induced magnetism at that point.
Yeah, but this is creating on its own. I'm not disputing that. I'm just saying that's a wicked one. It kind of got twisted up in itself.
Yeah, it was. It actually started. It started kind of the process in its own, like in the middle of itself.
Yeah,
like of like rab formation, and you could actually see that because you could see where the outer um lines, right there, those are going parabolic. You see how they're starting to sweep like that. They're turning into what do you call it, a Pringle. That's the step before rab formation.
Let's take a look. Let's go back through this because
That's really cool. Really, really cool. Oh, wait. Well, I'm sorry. Go back one more time for one more second on that one, because there's something present there that's important to show.
Okay, go ahead.
Look at how the stuff is intersecting. How it's intersecting is two lines at a 45 with a line through it. Okay. And that's literally visualizing what we've been saying all along about the field dynamic that exists when the field lines cross and you get the third, and then you get the compression in the center, and you could literally see it there. So if you look very closely, two lines crossing and then one line straight through it.
Yeah, I see it.
Mm-hmm.
Oh yeah. Yeah, I had to put this stuff together, Joe, for that presentation for Tesla Tech, and it gets real in detail when it comes to this kind of stuff because people don't understand what geometry does to things. They, run something like we look at it and they go, okay, how do you create an electron? And you put it in an array tube, right? And it says this little thing across, and then it goes to a bias. And you're looking at it and going, okay, but there's no little ball. There's no little electron ball, right? And you know me, I get frustrated with it. And I finally just came to peace with it, Joe, and said, look, it's just a field. There's no ball. And the only reason I came to that conclusion is because how they say the ion breaks as soon as you put two electrons together. He says it breaks off an ion. But ions don't come out of the fairy dust. So the ions must be in the center, right? So if you collide them, you're knocking one loose. So therefore, you must be trapping the ions. So that picture of the rab made perfect sense now. You got the little dots in there, right? And then it's wrapping around it, but then it goes dark. So the center core looks dark, so you never know what's in there. But that's kind of the thing. That's why it looks like an electron is the ball, but it's only the outer shell built in a field around it when you change to 360 degrees. So they're technically right that it turns into a ball, but they're wrong about how we got there.
Yeah, right. Well, the best explanation, I think, and I hate to say the best explanation is my explanation, but when I went on that paradigm drift show and I kind of pitched the whole how the rab forms situation, the whole entire idea was that it searches for the other thing, right? And when it starts pulling it through, it pulls it through. But then rather than them attract, they repel, right? That's the whole entire idea. Now, when you get your head around these things, if you take two magnets on a table, okay, and they're going to repel each other, and you're pushing them toward each other at a very slow speed, they're just going to drift ever so slightly apart, and then they'll start to attract, right, and they'll start to pull back together. But if you're doing it very slowly, okay, it's proportionate, so it's not that apparent. When you do it very fast, okay, that repulsion event's the same, but the diameters become much larger, right? So all of a sudden it becomes very exaggerated, and that's how these things end up building out when when you have high density levels of things. There's a lot. It's moving fast. It's got a lot of travel, and it's got a lot of repulsion, and it's got a lot of attraction. So these things expand large, and to increase the field geometry.
Well, they say in the magnet, what is it? The vector direction and each side of it, one is just more than the other, right? And that's what creates a north and south. Well, what is inside the magnet? Well, there's no electron inside the magnet. They don't form inside things. Ions do.
Right.
Ions form inside. So ions are getting a vector direction in order to create a bias from one side to the other. And that gives you your repulsion and your attraction to each one. And when they sit together the side by side, they cancel. Or
So here's the
the
thing.
fields, you can't see it.
So here's what's crazy, right? If you ionize something, okay, and then you have ions scatter in a state of diffusion, it turns back into potential, right?
Mhm.
It's only when the ions start to accumulate, they're still in a potential state at that point until they have vector. So what ends up happening is we would call it static or something like that at that point, because you have a single charge bias accumulation, in the relationship to what? Matter, right? Other matter. Does it start to make sense? Because if you let the energy go and it goes into a diffuse state, it just simply goes back to potential, which means that it ceases to have a relationship, which means it ceases to mean anything. Is it detectable at that point? No. Once it falls out the into diffusion, finding that ion is near impossible.
I think one of the most interesting parts, Joe, is when we found out that it was light creating these things. Okay, you see the light come off, you see that it goes through and it hits the lensing, okay, of a bubble on each side of it. And then it would go through and create these little dots. It looked like different colors. And each one of them was swirling. Then they go off and hit this little point here, and then boom, the whole thing builds out, right?
Mm-hmm.
So you knew the light itself was coming down, getting in a pattern of rotation. That rotation turns it into an ion, okay? But then when it's in material, that's slowed down to a massively crawl state because now they're sitting throughout the thing. There's still energy, but now they're throughout the material. They're not, compressed in the right way anymore. And I learned this from Hutchinson. When he started breaking material apart, he would take a very high ion material and then he would compress the ions, and the material itself couldn't handle the amount of energy inside, so it ripped itself from the inside. But his metal was stable before that. The only way it could be stable before that is if the amount of energy in each ion was in a reduced state. And
Right.
then he excited it to bring it back to the correct state to get enough energy to tear it apart.
Everything, and I think this is something that isn't talked about often enough because it's weird. Everything attracts and repels each
Yeah.
other. Everything, and I think that the more common thing that has been said recently is that you've never actually touched anything before in your life, right? Like,
Those,
right, when you go to touch something, there's no actual contact between this material and that material. It's just literally pressure differences that exist at the boundary layer of where these things are coming together based on attraction and repulsion. And some things have different densities, right? So if they're able to be compressed, then they squish. But if they can't be compressed, you know, realistically, the only way for something to then pass through is to break the structure, which is why, like if you press a nail or whatever into wood, the nail is going to overcome the wood, it's going to penetrate it, go through it, displace it, because it's harder, because it's repelling it. I don't know. That's what they're saying. I get where they're coming from with it. Um, it's just sort of like this weird thing though, where everything really does have a certain degree of it'll attract under these conditions and repel under others, right? That's sort of the point. Because energy and matter acts the same way in that regard. And if matter didn't work that way, then matter would cease to exist because there would be no condensation of material in the first place.
must be in micro amounts that you see that. You know what I mean? Because you see something in your hand, you're like, dude, it's in my hand, right?
Mhm.
But then you're saying there's like a little field in between. It must be so small you can't tell.
That's exactly what it is. I mean, it's infinitesimally small. It's just the fact that, there is always going to be space between the material at the smallest levels. Always. They don't press, like at the molecular level, these molecules are not pressing against those molecules directly in
Mhm.
any real sense. They're applying pressure, and the repulsion of it is that pressure is what's pushing it. So it's like you pushing the air, and that air pressure pushing the whatever, like if you want to think about it that way.
That was
Uh,
funny. Oh, by the way, it was foggy out this morning, Joe. Like I always tell people that we're in gas, right? And you don't realize it, but when the fog's out, you do. You know
yeah.
what I mean? It's kind of hard not to see it at that point. There's different layers going on all over the place.
Obviously, we're in gas. I mean, shit. How would you be alive? Like, duh, like, I don't know. Like,
Well,
and,
but
and
that's
well, okay, how about this? But gas is a fluid. Get your head around that one. It's just a loose ass fluid.
well, you would think, Joe, but a lot of people, when you say anti-gravity, they're talking about energy. It's energy repulsing from the ground. It's energy attracting to the skies, right? They're not looking at, hey, what are we actually in? You know what I mean? Are we looking at a volume of energy around us? Is there any kind of fluid, like you said? You know what I mean? Fluid dynamics in something. Like it'd be easy if we said water, they'd be like, well, of course there is. But then you say air, and they don't think gas. They think, I don't see anything in front of me, right? And then you go, well, take it on a foggy day and understand a little differently. You're in gas. So that means that there's a third thing to mess with as a medium that you're in. And that's usually left out of every experiment that I've ever seen is they don't talk about that, but that's the exact thing that's going on.
Well, I agree. And, thinking about fluid and hydrodynamics is always key to understanding this stuff. Like, if you don't fully understand that to the highest reasonable extent, then you have not a chance in the world of ever visualizing any of this stuff to be able to understand the greater understanding of it whatever. But one relationship that's very interesting in fluid dynamics, right,
Mm-hmm.
is this relationship between density and viscosity. Okay, that isn't what would seem to be, right? Like, for instance, if something's viscous, you would expect it to be dense, right? Well, oil is very viscous, except for the fact that it's less dense than water, whereas water is, moderately viscous at best, you know, and yet it's a higher density than oil, right? So it's just a very strange phenomena, because viscosity is extraordinarily significant when it comes to something's ability to easily snap into torsion zones. Its ability to drive, right? So when something's viscous, it's easy to create surface tension.
Mm-hmm.
And that's sort of what's interesting, right? So it becomes easier to structure, in other words, right?
Yeah. Yes.
Easier to hold the torsion boundaries through geometric manipulation of the fluid.
Well, I think it gets just as easy in air if you understand what controls it. You mean because
it's not that it's different in air. It's just that because the density levels are so low, and there is almost no viscosity, where you have to form it through, um, you basically have to form it through creating pressure differentials, which is exactly how you would form it the other way too. So you have to form extreme pressure differentials in order to create a wall that's going to overcome the rest, because at the end of the day, you have a lot of loss to friction because
so
everything's moving so fast.
here's the thing, Joe. That's why keep an account of everything that goes into energy matters. So for those who don't put entropy in there, it becomes a big problem when you get to structuring air. If you don't know that the hot and cold make a difference in it, right? So we'll just say an easy one, right? We have an ionosphere, we have an area of plasma, and we have a magnetosphere. We know we're building ions, we know we're building a general area in between it, and we know that we're building magnetics, okay? That's pretty simple. That's exactly what a field bubble is. You can go backwards on it and go reverse, but that's pretty much what you're dealing with, right? So you get two sides that are weak. They continuously say our ionosphere is a weak force and our magnetosphere is a weak force, but what is the strong force? It's the area in between. The air in between is the plasma. It's the cold plasma that goes on in between. So you go, I take two weak forces and make a strong force. For those of you keeping track and writing it down in your notebook, that's T.T. Brown's understanding of exactly how to do it. That exactly is a field bubble. We go to the 3M experiment. We have a cold warehouse. We have warm tape that's going around. The two right there create entropy in between them. You're creating a pressure differential based on the actual hot and cold of it, just like a tornado. So you're structuring it now. If you can understand that with a little bit of radiation thrown in order to pull the air itself into the correct structure, then you can start thinking about, man, I got a field bubble inside the air, inside my room right now that can be super thick. You can't put your hand through it.
So here's something interesting, right? Based on that, and super cool. If you think about thunderstorm generator and their little bubbler, okay? If they were actually, and this, I'm going to connect what I was just saying to what you were saying now with this, right? And you were to replace the water with a more viscous solution, okay, that still doesn't have a high density, okay, it's actually going to hold those water bubbles longer, okay, and easier, right? Because since the structure of the cavitation bubble, okay, can be easier achieved in the viscous solution, because of its, like I said, it takes less to structure it, right?
Mm-hmm.
Well, you can sustain that bubble longer through its transients up to the top, okay, which means that every time that there's a compression decompression event, it's literally pumping more and more vacuum energy through its building in its capacitance of the cavitation. So when it pops at the top and has the release of the bubble to form the plasmoid, okay, then you're going to get a stronger plasmoid discharge the longer you could keep the bubble in the pipe. You see? So, and that's where the viscosity of the solution would ultimately come in.
Well, in that experiment too, you got free ions. So you're ionizing the water in order to create extra ions. When you create extra ions, you're putting them in the center core of an atom and you're stuffing the atom. So therefore, you're going to create a different material that's going on right there. So if you took some ions out of carbon, then guess what? It changes what it is. It's the Russell scale all up and down. That's an ion scale. It's basically telling you exactly what to put in there. So if you want to create gold, you just need to know that, hey, if I took some mercury and I took some ultrasound to it, I'm going to get gold 117. I need to get to gold 118. So I need some free ions in order to add to it to stabilize the material so that it doesn't convert back. That's the same process going on in thunderstorm generator. In order to make some other material, you must, pack ions in there without destroying it and exploding it. And you must, just generally change it, which means all transmutation happens at the ionic level. That's why every time they bring it up, they're talking about ionization.
Exactly. And they know that too, which is why they have that plasmoid unification model. And where does this become relevant to what we showed before with what Sean was, showing us? Well, it's the frequency banding. Because when you then take that band and you add another dimension to it, it ends up with nodal points instead of bands. When you have nodal points, well, that's no different than an ionic lattice structure. So if you have an ionic lattice structure, last I checked, you're now in the molecular creation realm of transmutation. So, and it's based on the harmonic bands.
There we go. Yeah, it all ties back into each other as one. How do I say it? It's like I want to say it's a giant fluid that basically everything travels through, and it just depends on what you put into it. So it's like when you take gold and you start putting the acids in there and changing it, getting rid of any other materials, it turns into a liquid, right? And you're going, well, that was a solid metal. How was it a liquid? Well, then it go ahead and it'll transfer again back over to a solid state if you add the correct, acid or base to it. I found it fascinating. I'm looking at this and going, if we just simply look at the ions and follow the path, and we just keep a very stiff record of exactly what's going on here, we'd have every single thing in alchemy, no problem.
Yeah, Jarvis brings up a good point, man. You see what he said in the chat? Said that the dry path to alchemy is really thermite reactions. Yeah, oxides, always, because at the end of the day, you're storing the energy from the oxygen. You're going to get extra energy when you break the oxide bond with the metal. And the heat that's created out of it, if you set the conditions properly, right? You set resonant conditions in a thermite reaction, which nobody does, by the way. You just let it go atmospherically, ambient, right? So you're ambient is this, and then ambient out is that, and it's the same because the ambient is the same. But if you structure it in that process where you're breaking the oxygen off in this, volatile reaction, well, it's those are high energy levels that you're dealing with that are capable of transmutation if you add in resonance. I 100% agree with that. And oxides are always like that. That's why when Bernie's doing like all these electrolysis reactions and stuff, there's also hydrolysis that gets added into that too, when hydrogen gets involved in the acids, right? So it's these combinations. What does it all boil down to is water. Go figure, right?
Yeah. Well, that's why some things are unstable unless they're in some kind of a thing like water or something like that. So, some things have to be in that until you use the energy. You know what I mean? Whatever material you're in, something like that, it gets to a state of unstable unless you put it in a medium, and then it becomes stable. And then when you want to use it, you have to pull it out of that medium. And those are some of the fuels, that you want to use when you get into the higher end of physics. And most of the ones we use, man, we don't pay attention to that at all. We just burn the living daylights out of it.
Yep.
So I wanted to mention, by the way, when we saw the Black and Sean's experiment, and I don't know if I can pull the exact one, when it was coming down on the energy and you saw it wrap, around everything else, I just want everybody to know that's where that green color comes from. Everybody talks about it with UFOs. Oh, there's, you're getting a green color. The only way you get that green color is if you create the dark color that's in there, which means that you're packing energy inside of that at a higher density level than you are the rest of the colors that go on in that energy. So just think about that when you do that. That means you must have some kind of compression inside the air, some kind of bubble, something that's going on around those crafts in order to have a higher state of energy. Which
I can tell you what it is. It's energy. Comes back to energy exchange again. Okay, yes. and the infrared and UV spectrum, because when you have something, okay, that's dropping off the either side of the Planck scale spectrum, okay, it encompasses the full frequency from one side to the other. Okay, when these are in a state of energy exchange, okay, that's a non-equilibrium state. So you have red shift, blue shift, and then where they exchange is your equilibrium state, which is only very, very controlled. Okay, it's in proportion, it's very controlled. And where it reaches that equilibrium state, it hits the dead center of the spectrum, which is that group visible green. Okay, so whenever you get that green and you get the darkness, like you said, the darkness is because we cannot see it. All right, but it's because it falls off the spectrum on both sides simultaneously in that exchange. So that's what you end up getting.
Well, everybody worries about running into it. That if you don't have coupling in your experiment, you'll never run across it. And that's kind of the main thing. It's how did you build something around it? What are the layers around it? How did you learn to compress it? And a lot of this is basically people running in there and they just go for it. They just shove as much energy into something as possible and they think it's going to work. And they're not realizing in a bubble, it has to be coupled. It has to be counter rotating on one another. It has to create the locking phase. And you see it throughout different physics, even the atom itself, the way that each part goes around and rotates this way, and then this way, and then this way. When you look at it, it's creating a locking mechanism, and it's fairly simple. But that's what I'm trying to say here. If you don't have that, you don't have that coupling, you're not going to get to the higher energy state. So when you look at a UFO, just understand that they have high coupling going on the outside of this thing that's giving you the green energy state that's coming off it, because the rest of it will become translucent and dark because it's energy. That's the hardest thing to say. So when we say that it does the energy exchange, we see the dark ball on one side and the plasma on the other, and you say it does a figure eight in order to get there to create the energy exchange, right? That means that that dark ball, if everything shuts off and that thing has created enough energy in it, all the rest of it will go silent or explode and then go back to it. And it'll start sucking in like a black hole because it can't get to an equilibrium state without the charge side. So therefore, you're going to get a black hole effect that's going on inside of what you're doing there. It's a higher energy state. The compressor of the ions are so much higher in that little black ball on the one side than they were on the plasma state. So if anything goes wrong here, it pulls back there. That's why they always say, you know what I mean? Oh, we don't know where the black hole came from. I do, because everything has an energy exchange if it builds out into a solar system.
Yeah, that's it. I mean, if you have a point of emission, you also have to have a point of return. The thing is that more times than not, right? And the way that they found a black hole in the first place was actually this as a matter of a fluke, though, because they're like, how come we can't see anything here, right? We often try to explain the things that we observe, and the way that science is set up today is based on observation, right? You need to be able to empirically prove something, you know, and you have to do that experimentally. And it becomes exceedingly difficult to prove something by what's not there, right? And that tends to be the issue.
Well, here we go. We'll prove it right here, Joe. There's the little black dot up there on the right. There's both plasma on the other side. There's the energy exchange of the sun.
Mm-hmm.
It's proven. This isn't something that can be debated anymore.
I agree. I would love to see what the censor says about this.
Oh, we're going to get there. Trust me. I just want to show this so people understand this is what's going on. So Sumerian second sun, the plasma dot, the black dot in the back, there's your planet X right there. It's not really a planet. It's part of the energy exchange of the solar system. That's why they'll go out there, and I believe there was NASA reports that were done on this. They got out there and they saw a big dark object. They didn't know what it was, and it had mass to it, and it also had gravity to it, but they couldn't identify it. So then they dropped it off all the reports.
Sun, you know, it's just it's just the mirror. It's just the mirror effect.
So they say that, and they say in every single solar system they're finding these black dots and they're not understanding it. Well, it's pretty clear in this experiment. You could see how it works in an energy exchange. It goes in one side, and you think the part on the right is the lower energy, but it's not. It's the higher energy. Yeah. You get to the other side of the plasma, that's where it's losing energy. That's where the heat comes from. The other part's in cold. It keeps the energy in. So if we were in a solar system and the center part right there, as the sun goes out, then the dark part takes over and it sucks everything in. That's what they can't find. That's why they can't find it. It's because it's directly, you know what I mean? Right there, and you can't see it.
So what happens when you back the dimensions up? You know, you go up dimensions and look down, and you realize that that's just the outside of what's inside, and that inside and out are both simultaneously inside and out at the same time. That is full-blown entanglement, you know, and meaning that what you view as the black hole sun is actually just simply the sun, You see, that's all it is. It's
Mhm.
just, we perceive it as there, here, but otherwise it's actually combined. Because what's inside is out, and what's outside is in.
Shout out Jarvis, man. You another super sticker.
Yeah,
He
dude.
shouting out Crafter, Sean out there. Sean's our favorite guy, man. He does all these experiments right here, man. And
Right on.
it's beautiful to watch.
And while it's on the top of my mind, I know he's not watching, but I want to say happy birthday to Brandon. It's
Oh,
Brandon.
right on. Happy
Brandon's
birthday,
40th
Brandon.
birthday today. He's old as dirt. So
Yeah, Sean is a master at this stuff, I'll tell you that. So it's not like we didn't notice this stuff. For you guys see, if you ever see this, you see up there on the top that rock, they just drew it on there. And when you start to look at it in the way that they drew it, you start to really understand, hey, they saw the same thing we did. And then you look at the one at the bottom there, or excuse me, in the white before you get to the bottom, they still showed the black dot sitting out there. They knew this stuff, guys, long before we did. That's why I keep saying it. They're putting it in stone. They're saying, hey, we're smarter than you. Wake up. And instead, we keep going around going, oh, they're Stone Age people. And they threw rocks and, you know what I mean? Bang their wives over the head with a hammer to get them back with them. Like stupid stuff like that. And it's not that way at all. They were advanced civilization. And you can see it if you understand the plasma physics of it.
Yep, damn right. And with that picture that you're showing of the magnetosphere, that's exactly the energy exchange relationship that occurs when we're building the RAV, with the Earth being the RAV in this context, right?
Yeah.
So and realistically, the RAV is kind of much like the Earth, but just inside out, if you want to think about it that way. It really pretty much is. It's just kind of the way that it goes. It just depends on if the energy density is going to be concentrated on the inside, or if the energy density is going to be created, predominantly on the outside.
You know what I find funny here, Joe? When you see those big reactors for fusion, and I know we talked about this in length, but it still gets me when I look at this picture of how dumb it is. They pull the donut. So you see right there where the rainbow is? Right there next to the center core, you get a little rainbow that comes off. Okay, pretty clear in this picture right here. You see the different colors and everything? That's the band that they're pulling the energy out of. And then you look at the center and you go, well, where's the center of it? Well, it's a misunderstanding in fusion. You're missing the energy exchange in order to pull the energy out. You're looking at the gas that comes out of it, you see in every color there. So you're trapping the gas thinking you're going to get energy because it's plasma, while you didn't realize that the core had to look like this in order to create the donut to give you the higher energy state. And it's like, I don't know, it's like taking the peelings of the potato instead of the potato, right? Like, why am I dealing with table scraps versus what I really want? And that's what kind of frustrates me about it, because everybody goes, oh my God, I got this big Taurus. I got a donut. Sure do. And sure it is worthless because you didn't understand the parameters of it. And then you look at it and you go, okay, well, then I got red shift, blue shift. Well, when you get to the higher energy shapes, do you think that they're really those colors? No. They're plasma on one side, dark side the other. There's your shift. There's your center that you needed, where the energy is, and your donuts over there. Just I put sprinkles on it, man, because it's about worthless compared to the core. The core is like 1,000 times the energy of what you're actually pulling, so you'll never get over unity out of it because you're pulling the wrong area.
Yeah, that's a good point. Well, you have this picture up. Ashton Forbes said something the other day, and it's like, it's actually good that he said this. He was talking about the optimal stable plasma shape, for the phenomena being more or less like a tier type torus, right? Meaning that it's not a donut torus, a tier spherical torus, right? So if you look at this photo, you could see that that's exactly what the RAV is altogether. And this configuration shows it really well because you could see that it's squat at the equatorial plane, which is at approximately 45 degrees based on this configuration, right? Or no, not 45. It's like, I don't know, call it 2 o'clock, whatever. It doesn't matter. Um, anyway, you can see that it's squat at the equator, okay? And then when it goes back up, because it's still connected to the anode, and it's anode dependent, it actually funnels up toward the anode, giving it that tier. And realistically, because it's not perfectly spherical, that is a squat tier. And I happen to agree when he said that this is the ideal configuration for the stability because this is what it naturally falls into.
Well, yeah, but you got to remember that the sun's just an explosion over time. And if you can understand that, then you can understand this. As you pull this and it goes back through the wire and goes down to the other side, if you put a coil in between it and use it as the core, then right now you've already pulled the magnetics of the core and then you pulled the outer field of the core really fast in order to get it to transfer to the other side. Therefore, you have a burst of energy that goes on between it. And as long as you pull the burst of energy onto a secondary coil, you're going to pull extra energy off it all day long as it sloshes back and forth. That's kind of the point, though. It's the higher energy state is the explosive state. It's not the running state, it's the explosive state. Therefore, you must pull it from side to side, back and forth between two different points in order to get extra energy out of it. Right now, we're not even scratching the surface with the donut.
Not even close. It could be exploited so much further.
Yes. What I love about this, Joe, too, is if you look at the colors in the background, I know we're big on this. The dark is never without energy. And then you see in this experiment here, you're getting all kinds of different colors. You're getting the purple in there. You're getting the blue in there. You're getting the dark purple in there.
Yeah.
All different colors in the background of this thing.
100%. And then you get the mix of them in the green. There's a little bit of green coming through too.
Oh, and look at the light that comes off of it. Sorry. Where it opened up on the top and the bottom, you can see it very clearly on this one. It looks like a flashlight's going on.
It shines and it's in a total band, like it's in a straight line.
Yeah. We saw this in other plasma experiments that we did, and it's so interesting where that line comes in because you see it in suns and stuff like that, and you see things swirling on an axis and where that line comes out. And then you start to understand something like this. Man, this completely changes. If they just took the RAV, man, and they said, okay, let's go look at the universe and the solar systems, does it match? You'd find a lot of similarities, man, because it's all just plasma built out. As soon as you knew Jupiter was a plasma core, and so was Saturn, the game was already set, right? They already knew. So as soon as they knew that, they know if I have a self-structured plasma that can build out anywhere, I can show positively what each one of those ones react to in an environment, right?
Mm-hmm.
And then here it is. You're looking right at it. And it's definitive on why it does it. Now, if you put this thing in a shell, then guess what? Depending on what the shell is, you just change the whole energy structure, altogether, and you reduce the amount of gravity. That's kind of the other thing here. You guys realize this form is gravity. I mean, I don't think a lot of people would understand that. Like, if I said that this is the core of a planet, you go, well, the planet has gravity. You'd probably miss the fact that because it does this, you have gravity. If I said this is the core of Jupiter, you'd say Jupiter has a lot of gravity. But you'd never correlate the two together. You're thinking something else, right? And then you go to, okay, it's a core of Saturn. Well, all right, it's the sun. The sun has gravity, right? And you're going, I'm not putting it together, but it's an obvious understanding that it builds out based on the plasma core as your gravity.
This is a wonderful thing that you're saying because plasma core, okay, equals high energy exchange, meaning high energy potential still in the material for that energy exchange to occur. So you get the plasma core. And then you look at, Venus, and you look at Mercury, and you look at Mars. And what you quickly realize is that they're depleted, their material is depleted of its own energy potential into a low energy state. And therefore the energy exchange ratio has dropped off. They have less gravity, right? And they have no real significant atmosphere of their own. Obviously they have a little bit of an atmosphere, but no significant atmosphere of their own, because that energy exchange is so low. And that is direct correlation to gravitation. It's direct correlation to the material makeup of the crust of the planet. Direct correlation to whether or not that planet is still transmuting its own new elements, through its own recycling, energy exchange processes. All of those things. That's why they are the way that they are. Then you look at the ones like you're saying. You look at Saturn, Jupiter, frankly, even Neptune, any of them, out there. They're all in the highest possible energy potential state for matter, because they're significantly hydrogen. So those have the most energy exchange, and
So
that's energy exchange potential, right?
I wanted to say this. Just understand this, guys. Right here. If that's true, then you'd be able to create a dielectric and gravitational. Why do you think my gravity flyer loses weight on a scale? I mean, I just want you to think about this. I'm creating this thing in reverse where, I put the diamagnetic on the outside and I put the magnetic on the inside. And then I guess it's kind of conventional in the way that it still traps the ions in this core of it. But I'm creating the same thing. I found a way to make the fields work based on what they actually are. And then it pulled energy like this, so it creates its own gravity. And the more gravity that I can create inside of it, the less it weighs on the scale. That's why Joe always talks about the shell, because if this thing had a shell, then it'd be able to create the energy around the shell, which means the gravitation on it would be much more massive, which means that it would go anti-gravitational, which is the wrong word, by the way, but it would lose all the weight in it very quickly.
Yeah, right. Because you'd have the dielectric in there, and the dielectric would not only hold the energy in, but it would also create eddy currents of convection, which then increases the geometric component of the geometric magnetic component to another, axis, that doesn't exist when it's open, right? So that's why the shell, like you're saying, man, that's why the shell. Because you get more out of it than just material hold in things, It's a simple way to think about it. There's very monkey brain. Material hold things in. If you have a bowl and you pour cereal in it, you can pour milk in the cereal in the bowl, right? Well, I mean, yeah, it's like that, but it's, there's more to it because of the relationship of, the dielectric properties of aluminum,
So let's break this down a little bit so people understand this. Hutchinson, I told you earlier, you turn apart the metal by compressing the ions in the center. Why is everything lifting on his table? And this is the misconception everybody gets to. You think it's just simply an anode and cathode, that at the top he's got an anode and he's got a cathode underneath the table, right? And it's a field in there. What you're missing is he's using the Tesla hairpin circuit and creating an ion field. Now, what's so special about that?
Change the environmental condition.
If you take and saturate each thing with ions, it takes a different amount of time for each single thing to create more ions in it, right? Based on the saturation rate, it now will flow in there at a lighter than it's supposed to be because it's filled with ions. Just understand that. That means that the ion state itself is where your anti-gravitational takes place. is the core ability for that. That's why we say the outside of the craft, right? Because all that is ions from there in. That means that that's the part that the understanding begins at the fields coming out of it. So the center itself is anti-gravitational. So if you said at the core of the earth, there's no gravitation, right? Because that's where all the ions are, right? If I say Hutchinson is working directly with the ions in there in order to compress them together, in order to tear metal apart, but he uses the same thing as the field in order to lift things in anti-gravity. It matches how energy works. I mean, you really just got to understand this. The energy at a higher state, what does it mean? It means your spin rate inside of the energy is super fast. Then, in order to keep an equilibrium, one has to turn another way in order to keep it, right? But that's the exact mechanical mechanism that creates your atom to go this way, then this way, then this way.
Mhm.
So if we simply took away some of the physics here and all the garbage, right? And we simply looked at it and said, this is a purely mechanical piece of machinery that builds out right here in energy in the core in order to build everything out. That's why the atom looks the same. That's why plasma physics looks the same. That's why planetary works the same. Everything looks the same because it is the same. If you take the understanding of everything comes in as light, so you have the equal amount of energy coming in. The only conditions you're changing is how much compression goes in there, the energy state that's in there, and the size of it. That's it. Once you understand that, it becomes a mathematical formula. Therefore, it's a building code for everything. And you simply say, at the end of the day, I'm just going to have to invoke Occam's razor and say the simplest answer has to be the right answer. And if we're building fields coming out anti-gravity that match that same answer, there's no question anymore. You got to get rid of some of the names here and start understanding things on a level how they should be understood.
Well, listen, it's not like we haven't in the past, but we gave away the answers if you combine everything we've discussed, in this today. Like, and, with what Nathan's saying, right? And combine it with what I was saying before, right? I was talking about things going into a state of potential. And if it gets thrown out into diffusion, it gets thrown out into diffusion. What good, right? But it likes to accumulate. So what happens when you accumulate all this potential, and it builds out and it builds out and it builds out? It ends up eventually in a state of diffusion, but it's gradient. Okay. So what that ends up doing is it ends up interacting with the environment in that state of diffusion because we're not in a vacuum, even when you are. And what it does is it creates, ionization of the environment. And that ionization gets drawn in. And then as it goes through, like the raft, think about the raft here, right? They're coming toward each other. They should attract, they're opposites. They should attract, but they repel. So it gets drawn in until it gets repelled. Well, hold on a second. You have a high energy density state surrounding this thing. You're drawing in this charged, environment, and then you're pushing that environment away. Well, if you're doing that, you're drawing it in and putting it away, sounds like you're in a bubble. Well, if you're in a bubble, then are you related to your environment? No. You are not related to your environment any longer because that environment is being drawn in and pushed out. Now you're in your own thing. Now you're relativistically, you're no longer relative to the gravitational force of your location. You're relative to the gravitational force of that inside the bubble. If you are what's inside the bubble, you are relative to the gravitational force of yourself, which means that the only center of gravity is based on the geometry of what's in that bubble, which is why things move, and like they wobble because they don't feel that because they're not relative to anything to change that perception. But because they're in the thing that the gravity, new relative gravity is in, you're still sitting in your seat because you're still pulled down to that. And because it was great enough to overcome the ambient gravity of what the environment you were in, it's at least the gravity You experience at least the gravity of the ambient that you had to overcome. And the thing is that it's self-regulating because of this diffusion thing. So that gravity that you start off in is pretty much the gravity that you experience the whole time that you're in there.
Yeah.
That's the best way to put it.
You know, I find it hilarious, Joe. This should be the simplest test. Go to any planet, put basically a little bubbler, kid's bubbler, and let it go off, right? It's going to act the same way in every environment, no matter the gravitational force, because it creates its own gravity. I mean, just think about how simple that is, but how complex it is once you look at it. If I blew a bubble, right, you'd say, man, that's got a prism in it. There's all kinds of different colors on the outside. You know what I mean? But then I have a very distinct feature when it gets up in the air. If the geometry and the distance in it is correct, you'll get a beat frequency between the red and blue shift, and then it'll rise. If it's incorrect, it goes straight to the ground. Just understand what that means. Go out and blow some bubbles with your kids and figure it out, okay? As soon as they're correct, it rises every time. When it's incorrect on the amount of the diameter of it, it drops to the ground. The blue shift, it goes whoop. But if that means that it doesn't behave in nature like if you threw a rock in the air, right? And you say, well, the rock weighs a little much more. But if the rock was inside the bubble, it wouldn't. It would simply float away.
And what is deterministic of that size and that stability is the spin. So when you blow the bubble, and there's a little bias on one side, it starts rotating around, right? If that rotation, what is still like present as it breaks free and clean, then it's still got that factor to it. If you blow it slow and it just kind of makes it out, it always drops because you didn't put enough spin into it to stabilize it.
You talked about teardrop with Ashton. He was saying it a couple of days ago. That's exactly what it's doing. It teardrops before it turns into the bubble.
Always. It is a teardrop. It has to be, because then it can't pinch the end closed. And that's what if you remember when I was talking about rad formation, I talked about this parabolic sweep, right, that would occur as it turns into the vortex. The vortex pinches closed. That's the point. And that's when you get the dimensional change of the magnetism. You get the sphere, and then it's still a teardrop at that point. Mm-hmm. Yeah, so it's all about that pinch, baby.
I just think it's kind of funny because nature's telling us this, and people think, oh, it's in physics, so we have to follow all the physics words and everything like that, right? What they're failing to see is if we just put the words aside and we follow the energy, what is the energy telling us? Is it so much simpler on a smaller scale? Has it been in front of us the whole time? Is this why ancient cultures see it before us? You know what I mean? If you're not over here trying to convert something to a different language, then you're fluent, right? Then it becomes easy to understand. But when you're constantly going back and you're converting it over to a different language, you're having a problem, okay? In physics, at each level, they're so compartmentalized, right? So you go, oh my God, it's in plasma. They're speaking Spanish. Oh my God, they're in string theory. They're speaking French. You know what I mean? And you start to get that same understanding. And you're going, now I got to convert to all these languages. What if I just look at the energy? It's pretty much English the whole way through. It's fairly easy. It works in the same pattern every time. It doesn't change much unless you change the condition upon it. And then you have it. That's the only thing you have to do. It's not so much that the names, you get lost in them, because 1,000 different people get lost in the names. I get corrected 100 times over on what the names is. You know what I know that you don't know? Is I build the energy in the garage. I built it. So I'm looking at this thing going, this looks like this, and this looks like this, and it's reacting the exact same way, but they call them different things because of the particle size. And I'm laughing to myself going, do you know how ignorant that is?
Oh.
Like, I'm sorry, pal, I can write this whole thing based on energy, and you would be completely clueless on it because you give it all different names. That's about how simple it is.
We've experienced what these higher energy levels are like. And the thing is it really makes you have to think about CERN, because what they're doing has got to really, like, you know, like with the power levels that they have going on there, and what they're doing, you know, it really should open your eyes. Like, there's all this conspiracy shit around it, and like, take a lot of it with a grain of salt, because people will take a snippet of truth and run with it like it's nobody's business. But
Oh yeah.
what I will tell you is that there is no way on this entire planet that you run those high energy levels in the way that they do. Forget the collision. Just running it with all that magnetism, looping electrons around it the way that they do. If you don't think that that in itself is gonna fuck up the physics in the entire area, like, that's a total delusion. Like, because all that they're doing is creating the same thing that we've been talking about, because it's a circle and it's an accelerator, and you have these large acceleration rings of magnetism at specific points, okay, underground, mind you, in an energy field that it's separate of, okay. Now this is creating a secondary energy field at each accelerator that are then working as a larger energy field. So the field dynamics that exist in that entire area is like the same energy exchange situation, upper dimensional energy exchange of magnetism that's occurring. And then you're shooting the frigging electrons around, which is then, gonna screw with the energy density levels in the ground, drawing that in, because they're bringing hot electric in, to create the magnetism. And the ground doesn't work off of that, it works off of the opposite. So it's drawn in, increasing the density levels of the ground energy in that. If you follow everything that we talk about, and then you're following what I'm saying now, it's sort of like, yo, there's no fucking way possible that when they're running that thing, like, there could be weird stuff that people, and this is the weird thing, people may be none the wiser. Like, there could be like weird stuff, like they talk about, like timeline slips and stuff, and
Yeah.
you'd be totally none the wiser, because, like, you wake up and you go about your life, and your life is different, but you forget the friggin' life you lived. And it's like, what? Well, hold on a second. Phasing in and out, and it would, because it's in the ground. That permeates the earth, like, as a whole. So it's crazy
Well,
shit, man, that they do over there.
well, let's take a look at it. If you're in a pure energy state, Joe, and you know that the speed of the energy inside that ion zone is much faster than the outside of it's much slower. You're already creating a time dilation. Okay. You're already changing the time between the two as soon as you created it. It immediately did it. You didn't even have to think about it. Immediately did it for you. It created the time dilation. Well, what happens if you're in the core of the time dilation? I mean, start to think about what that actually means. It means that you're not only creating an anti-gravitational craft, but inside of it, you're in a different time field than you would be around anyone else. Just think about that when you start thinking about a UFO. How does it move so fast? Well, its time is different than yours. Okay. Einstein himself pointed this out, special relativity.
Its distance is different than yours too.
Yeah. So you're going to sit there and you're going to be going at a much faster rate than they are. They're going to be slow compared to you. They're going to be like snails. So it's not that they're moving faster like they had a propulsion system beyond anything on this earth. It's that their time dilation is different. So if you take that into account and you say, okay, if the time dilation is different, and I know they're structuring air to get to the medium, there's no inertia on their craft, so they can move anywhere they want as fast as they want. They can change direction, because to them it may be a slow crawl turn, but since they're in time dilation, it looks like they go whoop immediately, right? It doesn't mean anything. They're just so fast.
That's a good point, but there's like a whole other like perspective to look at it from too, which is weird, which is that since you want to link time and space, and honestly it is, you know, you know, if you could slow down time, that means that you're expanding space. Okay, and if you're speeding up time, that means you're constricting space. So, or no, opposite way. If you're constricting space, you're slowing down time.
So why would it
You're slowing
just
down time if you're constricting space.
just ask you, why would it change space? What's the dynamic?
Well, because they're intrinsically related. And if you constrict time, okay, then I'm sorry, if you constrict space, then you're slowing down time. And if you expand space, then you're speeding up time. Okay, it's an explosion is fast, and an implosion is faster, but only relative to your perspective. Okay, that's the idea, because distance becomes, right, time and distance annihilation, right? That's the whole idea between time and distance annihilation, is because as you annihilate time, you also annihilate distance, not because time doesn't matter, but because you not only do you not experience time the same way, but also because space becomes constricted. So when space is constricted, and your time has slowed, you could get from point A to point B nearly instantaneously, because you are experiencing time slowly, and because space has gotten smaller. The distance has gotten smaller. So it's sort of like, if you want to think about it, you ever resize an image in like photo software before, right? You pull the corner, right? Well, if time's going slower, everything's getting bigger. So the faster, right? So if you're going, so when your time's moving very fast, everything is also further away. And when time is going very slowly for you, everything is very close.
So
and that makes sense, because when you constrict things, that means that the energy exchange is more concentrated. You see, higher energy exchange, higher energy density.
So let me say it in this way, and I don't disagree with you, Joe, but I'll say it like this: when you compress the ions at the core, the distance to the outside changes, is what you're saying, right? Because you stretch it or do it, right? And it's not that it's actually different. And here's how I'll say it: when it builds out in layers, it builds out in frequency. When those frequency builds out in layers, there's still the same frequency in each one of them, but now you compress the core to different levels, so your gravitational level is different inside there, right? But the frequencies are still the same coming out of the bubble in which you're in. Therefore, if you know how to transverse the frequencies from this end to this end quickly, then when you stretch it and constrict it, guess what? Those things appear longer, but they're not any longer to you, because you are transversing the same amount of space. That's it.
I get that. That's relativity, but there's also space. Again, time and space are.
That was time and space. The time changes as you compress the core, which is time dilation, right? Yeah. That doesn't mean that it's changing the outside layers of it. It just means the core is changing.
Yeah.
Which means
it happens in the cells in our body. It happens on the microscopic scale or small scale, all over the place. What's weird about localized time dilation is that it happens on the very large scale, and it happens in the very small scale, but it's exceedingly rare, in the scale that we experience, right? That's the weird thing about it. Mm-hmm. So like, there's certain things that based on your energy exchange rate of your own self, right? With your brain maybe acting and your nervous system acting as a upper dimensional antenna or cage for your plasma higher dimensional self, right? If you influence that energy exchange rate between your nervous system and your plasma state, well, all of a sudden you then experience time differently, and your body attached to it in its general field, okay, its aura, experiences that time differently too. And this is what happens, when we sleep, right? You go to
Oh
sleep,
yeah.
all right, you dream, your subconscious or plasma self or higher self or whatever is literally in a high state of energy exchange. Time blows by, and as soon as you close your eyes, it's sort of like you just, you wake up no time later.
Mhm.
That's, so I mean, that's like you'd say, oh, well, you're just not aware.
Hmm.
That's not it, because anybody who dreams knows you could feel like you've been asleep for while you're sleeping for like ever. you know, you could feel like you've been asleep forever, but
Oh yeah.
when you wake up, your discernment is that you just went to sleep, more or less.
Yeah. So, sorry, I'm reading the comments as well, Joe. So I see what everybody's saying on this stuff.
Yeah.
Hmm. Yeah, there's everything that this does has a reaction to it. How much gas is in the field, how much you're breaking down things, but it also pretty much stays the same way. I mean, think about this when you're driving a craft with your mind. If you're not the Green Lantern in there and have a focused mind, you're going to come out trashed. Okay. You'll never make it through the process because your body's going to endure whatever that craft endures. Your physical state to your every single thing in your body, how all your muscles contract and everything like that, that whole system, your nervous system, it's going to feel like the shell of that ship. So as it experiences it, you experience it. You are directly tied to it. Your brain is out there trying to process all this information. So if you're not rock solid, if you're wishy-washy, you know what I mean, you're bipolar, it's going to be a hard day for you. You're going to probably tear your mind in pieces. Okay, but if you're like me and you don't have a whole lot in your head, you're pretty much okay. You could focus in one direction and go, right? That's kind of the difference. You have to be in tune with it. That's why they keep saying it, because as soon as we start dropping things, just to be very honest with each other, as soon as we start dropping things in the hertz level, when we get into resonance, your body starts to react. There's no question about it. You talk about Schumann resonance, you talk about crystals. We're in the hertz level. We're not in the megahertz or the kilohertz that are not going to really tie into you as much. When you get into the hertz level, you are ground zero for it to happen. You're
You
going to
gotta,
start
you gotta
feeling
remember,
everything.
Schumann is beat frequency relationship. It's an offset differential, but it's an offset differential of things that it's non-material in its nature, right? So you know how matter has its own resonance based on whatever it is, right? Well, human resonance is a whole different animal, even though it's Earth and Earth is material. Well, why? Because it's not a material resonance. Okay, it's material that's induced. Pardon me. It's material that's induced into a state of forced resonance by the stronger energies at work, which are the plasmatic core energies, the high energy states of the core and mantles of the earth. Okay. And the offset beat frequency relationship between that core plasmatic energy and our upper plasmatic atmospheric energy. Okay. The two of them have their own independent oscillations, and the offset of the two is the Schumann resonance, which then the material that's wedged between these two plasmatic forces is forcing into a state of oscillation. So they have its native oscillation if you were just left it alone. But at the end of the day, because of that relationship, it's forced into that beat frequency, regardless of what it is, which is why you have material breakdown that occurs, okay, because it's forced out of its resonant frequency in high energy states, right? This is
Mhm.
why you have different, you know, uh, continents and different, shields. And this is why there's not a solid crust and everything's kind of broken apart and floating and moving is for this reason. It just so happens that at the surface level where the atmosphere meets the Earth's crust itself, right, it's like the chill zone. Like, it's where it comes together and it kind of is most stable,
Mhm.
So we don't really see it that way, but this is the way it is. This is where Schumann's comes from. It's this force beat frequency between these two plasmatic energy forces that we're totally subject to all the time.
Absolutely.
Yeah.
I think people miss that a lot when they do some of this stuff. They don't realize that you're going to that level. When you get to the Hertz level, it changes things completely. So you go Tesla's earthquake machine, right? Pretty much the same thing. He's in the Hertz, man. That thing was going slow, and people are going, "Oh man, it's too slow. You're moving the magnet back and forth. It's not giving you what you want." But then you start to look at it and go, "Man, he's at a really low frequency. Man, it's taking a long time to get there because at low frequency, remember your waves, it's much bigger. It's not small and confined. It's much bigger. So now it takes time to get there to get it done, right? Then you get into the water hammer and the steam hammer that was going on in there, and you go, man, as he's doing it, he's amplifying each side of it with a pulse wave, and now he's creating the energy inside of it to rumble a building. And you're going, how does something so weak, so small, do it? And it comes down to, did you understand the mechanics of what he did?
You're dead on. And here's the point that people don't realize about needing these high energy density levels for things. Okay. You're never going to have the energy density level of the plasmatic core of the Earth. You're never going to have the energy density level of the atmosphere. But because of the low beat frequency, if you fall into resonance with the beat frequency that is born but for of both, you will be in resonance with it all and therefore have the energy potential availability of it all.
Yes.
And that's why Schumann's is so fucked up. And you got to be careful with it, is because not only is it resonance, it's also constructive interference. Okay. So not only do you bring in that which you've become in resonance with, but now you're amplifying it. And you're getting both sides. Both sides. And that's why Schumann's is a very dangerous thing to actually mess with. It truly is. Like, and people they'll be like, Schumann frequency healing, this, that, the other thing. Yeah, that's cute when you're pumping it into your ears, and it's just like not at a high enough level to actually bring your body into forced oscillation at that low frequency. Okay. But force something into Schumann's resonance, where the whole entire thing is oscillating at exactly that rate, and watch what happens. Watch, because it's not okay, and it's not normal. There's especially if it's conductive. I'm just saying.
Oh yeah. Oh, it could be very harmful to you if you put the wrong.
You
get tied up in the wrong frequency. Yeah, you're in trouble.
Yeah, right. That's it. If it's non-conductive, it'll do weird stuff like start falling apart, dematerialize, start to float. Things like that. As it bounces between this and that, because we're literally on the cusp of both.
I was looking at something today, Joe, and I'm thinking about it, right? We're doing energy going into everything. For those of you who didn't watch the video before, cold energy is simply the ion energy, right? And it pairs with another ion in order to create your electromagnetic right there. And we see it in capacitors all the time. We say it's cold energy goes in, right? Goes into the capacitor, turns into regular energy, in which we know. It's the simplest conversion you can do. It works that way. And then if you start looking at the answers of cold energy, you say, well, you have to pull it through the wire. You have to create a draw. You have to create a hot side on the other side, like a light bulb or something, and pull the energy through, right? Or in Mike's Renegade circuit, we basically took the light bulb, and when the light bulb goes in there and it has too much to it, and you put it in there, it doesn't light up anymore. But what happens is the amount of energy going back to the battery is much higher. But then when you put in there where it can take it, it'll just blink all day and waste the energy, right? So what are we doing? We're just simply taking and converting it right then and there in order for it to go into the battery. So you think about it and you go, oh, well, that's pretty simple, right? But now you think about the energy exchange and the way it works. So we'll go between a ionosphere and a magnetosphere, and you say there's that layer of plasma. Well, as you combine things, it's going to be created the plasma that goes on inside there. That's your paramagnetic layer. So you got a diamagnetic layer that's in your ions, you got a paramagnetic layer, and then you got a magnetic layer, and which is ferromagnetic. And now I challenge anybody out there to go and take an atom, and I just want you to look at the neutrons. And then I want you to pull up and cross-reference to it what the actual magnetism is in that area, right? So you go, okay, if I said I had a whole lot of neutrons in there, right? Is it ferromagnetic? If I said a whole lot of, a whole, like very no neutrons in there whatsoever, right? Is that diamagnetic? See, I think you guys miss this when it comes out to it. It's a very simple conversion. We know what they're doing, but now we can manipulate it with the atmosphere as you're pulling energy from it, so we can get a higher amount of ions in there to convert over to make electricity when you do cold energy experiments. That's why they're amplifying the energy, because they're coupling with the open air energy around them to understand this. It's not hard once you understand the dynamics that go on here. Why is it a high energy state in the middle? Because it's where everything couples. It's not the heat level where it's creating, loss. It's the very cold area where the energy couples. That's why it's paramagnetic, right? But it likes to force it off of each side, just like you take aluminum, right? So now you take aluminum, you go, it's paramagnetic. Well, what are the properties of aluminum to energy? Well, it creates everything off the surface of it. Now you're understanding that it's hard to get over the hump or hard to get over the material to the other side. Yeah. And then now it clicks. Why is that so much stronger? It's because of that single process. It takes so much to get back over it that it now has to slow down. Once it slows down, it's a clamp. It's a boundary zone. It no longer allows you to go fast. It slows everything down with the energy, right? But then it speeds up again on the other side, and it speeds up on the other side. And you're going, oh, now I see the air connection. As soon as I change the temperature in the air, I've changed the dynamic. Space is cold. Our planet's hot. I'm using entropy right then and there, and I didn't even realize it. Okay? This is why Coil experiments, when Gerald came on, I tell him to use an entropy. You're already using hot and cold. You don't even see it in the center. It's all ions. And as soon as you create that hot and cold, you create a rotation. Once you create a rotation, you're now pulling the environment because it vortexes. Now it's like a tornado coming into your coil while you're doing this. And you have a higher energy state coming out of it in the ions. And then what does he do to convert it? So just think about this. If you take a ferrite core and you wrap it with wire, you're creating the heat structure. You're creating the draw to the ion. You're drawing the ions into the heat structure of that core as you're pulling out the energy. Think about what he's doing. This isn't very hard. This is simply follow the energy, see what it does, see why it's doing what it does, and it explains every single bit of electrical engineering as you do it.
It becomes a lot better to visualize when you zoom a bit further than maybe we typically do. Because when you start looking at galaxies, and then you realize that stars are all plasma, and then the entire galaxy is bands of plasma, and it's all spiraling toward a common center, and if you look at the shape of them, they're generally round dish shape, meaning that there's magnetic component that exists, right? It's just rotational, two-dimensional magnetic component. Same as when the RAV is first initiating and the conditions are still established. Okay, so it reaches around for the energy connections, and it's creating plasma that's just turning, right? And that's the state that it's in, is that turning state. But what do we know? Well, if it manages to turn faster, if the density levels get higher, I should say, as the density levels get higher of the plasma, well, what ends up happening is it increases in its density that's going to sweep it and then bring it up that dimension magnetically. And these are things like that kind of occur, and it's crazy shit. It really is. But when you zoom out, you see it. And
Yeah.
how is the plasma formed in those galaxies? It's banded. It's banded. That's the whole entire point.
Mm-hmm.
It's all structured out that way, and it's all got a spiral bias.
Yeah. Have you seen the Oort cloud, Joe?
I mean, yeah, it's pretty rapid.
Well, it's basically like a ball of energy, right?
Yeah.
We're not talking anything different than what we're talking here. This is why I love it. It all matches out to what we're doing. Let's see if I can't share this.
Yeah, while you're sharing that, dead fish must be having a holiday, because all these disclosure things that they're talking about recently, and all these eyewitnesses coming forward saying stuff, almost every single one of them are talking about a crystal that glows red and orange. I've heard it
got that video
over and over and over and over again. And it's the same exact thing that he described to a T in his documentary, which was, by the way, for anybody that hasn't seen Dead Fish's documentary, it's wildly, highly recommended. It's
oh yeah,
it's definitely my style. I like that way of storytelling, so right on. And yeah, man, that's got to feel so good to be that vindicated, because it's just so many people that are saying the same thing. And you want to know something funny? This actually kind of like, it slipped my mind, but there was like this one time when I was a lot younger. I was in high school, and me and my friends were like sitting out on the bleachers at like a school, like drinking beer and smoking weed or something, and we were just hanging out and having a good time, and all of us saw it, man. It was like there were like these, I couldn't tell you how many, but there was more than one or two. There was like a few of these bright red, orange balls, but they were very far away. So had they been closer and I saw a crystal thing, it would have immediately snapped in my head. But I kind of like repressed this for a while. But anyway, there were these spheres, and they were doing all sorts of crazy stuff. And like me and my friends were all like, "Yo, we're watching it," and it was going on for minutes. And then they did the classic zip out, where it's like they're far away and they stay still, and then they go moving around like this, and then it goes, that's it. Guess what? If it was today, I'd really, really, really question, like what I'm seeing, as far as like, is this something weird or not? Because like, it was motions like drones could kind of do, where it's like up and then sideways and then down and all this stuff. And I would really question it at that point. But back in like 2002, yeah, nobody even knew what a drone was. Like, as far as like, common use. And they're definitely not going to be flying that if it's secret over populated areas. So,
but what I find interesting about it, Joe, is like when light doesn't come down, when the energy comes through and it goes through the shell of the actual Earth, and then it hits the glass, it creates a reflection back, and when it does, it creates those little orbs that you see, different color ones, right?
mm-hmm.
So I always look at it like that. Okay, in that kind of mind frame, if we see an orb, there must be something that's working on the reflection. So when Mike did his and he created his little motor down there and created his pyramid, and then he had all the energy from the power lines over there. He was creating a reflection to create the orb up there, right? And he goes, "Oh my God, there every time I turn it on." Well, yeah, there's a reason for it, Mike. You know what I mean? So I think of the same thing. I go,
He's projecting it because
right,
that's what pyramids do. You know, like they project.
exactly. So I'm just wondering, okay, if that's true, is there something that you're not seeing that's creating that bouncing effect? Is there a shimmer somewhere in the atmosphere that you're not seeing that gives it to be able to bounce off of it to create the orb, right? Because you say they go out like a UFO, but they're an orb, and you know the orb's light.
Like Skinwalker Ranch style.
Yes.
You know, right. And that's sort of the deal with it. Like, okay, I mean, this is just a theory, so I don't know. Like, I mean, half of what I'm saying is I'm probably just totally full of shit and doesn't matter. You know, like if you project a certain density level, right, at a certain frequency, and you're projecting it, and it's going into a state of wave function, call it, right? It's going to collapse at a certain point. It's going to collapse the same as scalar collapses because that's what wave function is, a scale. All right. So it goes into wave function and it's going to collapse where it meets coherence once again. And then that's where you're going to have your accumulation. So, you know, that's sort of the idea. And then what do we know about that? Well, then your energy comes back, right? But because it's still projecting, it's actually just bouncing back and forth. So now you have this here, projection, collapse, return. And then what do you get? You get the return in your cell. Right? It's kind of funny to think about like that. Here's a dumb question about, and I'm sorry, I'm not trying to go off topic, but with dead fish in the crystal, right?
No, go for it.
I just want to know, do we think that it's actually crystal, okay, or is it virtual crystal?
Mm.
You follow? Because realistically, if you're using high energy, you're using cymatic structuring and resonance in the first place. Is there actually crystal there? Or is it what we perceive as crystal because it's in the same lattice structure and utilizing the same refraction? You know, because these energy fields have refraction, as you can see from all of our rad experiments.
Hmm.
You know, it's probably you know, it could very well be virtually structured, you know, energy statement matter, right? Virtually constructed with the same refractive index as that which it's emulating, which is crystal. Why crystal? Because why quartz crystal? Because under stress it puts out more energy because it emulates higher dimensional geometries, right? We say I'm piezoelectric.
Well, if you think about it, it's energy coming from the ground, right? Is what we saw in the video. And it seemed to me like, how to say this? If you've ever looked at a topographical map, it would show you of the actual Earth, it'll show you vortexes all the time in the Earth. Okay. And if you looked at that and said, okay, I need the vortex to shoot the other way, but I need to structure the air. So I'm going to pull it just like it was a phaser blast, right? So, you know what I mean? Like a Star Wars blast, and it comes out in bits and parts, and boom, you know what I mean? Just like this, but it does it at the same frequency in the Earth itself, which means it's a very low hertz frequency, which would explain the timing on it and how it was so consistent. But if you could get a vortex to that, then you can pull energy out of those consistently and just add energy to your craft in that way. Now, is there a crystal under it? Not a crystal under it. Crystal under it would be great for the frequency itself because it would be low enough. The energy state of a crystal, using that would be using the ions. If you got an ion crystal, is what it came from. So it does make sense. You know what I mean? In the entire way that it forms and goes through. So I'm okay with a crystal or a crack in the earth that basically had the same harmonic frequency that would be able to pull the vortex.
Yeah. Either way.
Yeah. I like crystal because probably like him, I would love to take a craft and use crystal in there as my energy source in certain things, because it actually would work even better than everything else, because in all these little computer chips and everything they fry, those crystals don't fry. Not like that. If you keep them in the same resonance, they stay together. Like Joe found out, as soon as you don't, they break apart.
Mhm. Now let me ask you something. What do you think about tornadoes, bro? Like actual tornadoes? Because there's an interesting dynamic that kind of exists, right? Because you have high and low pressure that, is fundamental to actually being that exchange that creates the chase that is the vortex, right?
Mhm.
And but at the same exact time, they really only occur, in certain type of storm cells, and those storm cells are always associated with high charge, at high atmospheric charge. That's why
Mhm.
there's always lightning with them and stuff like that. Same as all these other things. Anytime that there's like lightning, you have to associate that with an energy exchange between the atmosphere and the earth. Um, so it's just unusual to think that, seldom do you get a big tornado, which they really chalk up as high and low pressure system phenomena, but what about the charge? Like what role does charge play in that, Because it has to. That's the
Mhm.
idea. It has to. I feel like the conditions that set it up are the pressure conditions.
Mhm.
But once that pressure condition is made and it starts to swirl, it's just a huge high charge energy exchange between the atmosphere and the ground.
Yes.
That's that's what I think
Mhm.
about.
No, I'm there with you. So if you think of the cold as the ions, and the heat of it is magnetic, and you put them together, then you start to realize that the center of it should be structured right, so that you shouldn't have any inertia whatsoever. And what do they say about the eye of the storm? It's the calmest thing in the world. And I don't know about you, but I've never seen something come down from the storm too many times. It gets to the center and it sucks up in there. Those things are generally gone. I always wonder if there's a bunch of people in space floating because of that. Just it's kind of a weird thing, but
Yeah,
whatever.
there's a lot of stuff gone, like, being in the center of a huge tornado where there's literally just torsion walls, like, surrounding you, and like a state of like laminar flow.
Hmm. Yeah,
Like, it's not only is that fucking crazy, okay, but like, yeah, I feel like that's some definite Bermuda Triangle shit.
oh
Like,
yeah, oh
those
yeah.
are big Bermuda Triangle question marks there. The thing is that the nuance to it being that you have to have survived the wall of nonsense that's about to hit you, in order to get to that second part.
Yeah.
But the quiet makes sense.
Hmm.
I mean, it shouldn't make sense because the world is literally falling apart in every direction around you, but it makes sense knowing what we do.
Well, okay. There's so much torque going on in there, that basically in the center, all of the gas is pulled to one side or the other. So the center wouldn't have any gas in it. That means it doesn't have
The
anything
vacuum
in
thing.
there. Yeah.
Yeah.
But then again, that talks about Schauberger and exactly how he thought of how engines should work in an airplane. If you create the tornado on the side, it self structures, and in the center, it pulls you through, because there is nothing in your way. There's no gases. It's all pulled to the side at that point, and you can go straight through it. Right. That's the same thing as a tornado effect. We see it in the eye of the storm. There's no gases in there. Okay, you'd probably choke to death or freeze over or something like that when it comes through there, because all the things you're used to in the gas environment are now gone.
Yeah,
It,
well,
it
I
may
don't
seem
know that you'd
still,
be
but they're
able. I
gone.
mean, it's like breathing, in low pressure situations. You got to remember when it's a low pressure situation, you really can't take a breath physically because your body is not strong enough to overcome the pressure differential. And
Yes.
therefore, because your lungs are going to be in a higher state of pressure always, because that's what they do, is it pressurizes the air. You breathe through your mouth, which is this big, that goes through your trachea, that is this big, that then goes through your the bronchial tubes, that's this big, then goes through the smaller subbronchial tubes that are that big, then goes into capillary action and shit, and into alveoli, which are microscopic. Well, last I checked, anytime you're bringing in something through a big pipe and then squeezing it through a whole bunch of little ones, that's massive pressure that's going on in there, which is necessary for it to be able to infuse itself into blood. Like if you're going to get oxygen infused in the blood, it needs to be under some crazy pressure, right? That's how our body does it. Well, I mean, if it's low pressure out there, beyond a certain threshold, you literally can't bring, it sucks all the air out of you and you can't take any in. Try to, hang your head out the window of your car doing 70 miles an hour. Tell me how you doing.
Yeah,
like,
not very well.
you're not breathing. Like, you're not.
Well, that's interesting because they always talk about like vacuums and stuff like that, but that's a true vacuum right there. So, but that would give rise, that would be why propulsion works in that case, because if you create a vacuum, then it pulls through your propulsion. It's completely different than the force we use now as a pushing force. It's a pulling force, and it would pull you right through. That'd be your propulsion. So that makes all the sense in the world when you really get down to thinking about what things are. I mean, a lot of it's that way. So I think that's what people are missing in some of this stuff. I think it's interesting in that MH370 video is you can create the orbs right there with lasers. There's no question about it. You can create the plasma, find the line that it's on, the frequency line that it's on, make sure that there's something working inside the plane in order to put out the initial field. You can put it in there. What I find interesting is the end of it, where it looks like it goes out of the dimension, if you want to say it that way. And I look at that and I go, okay, Philadelphia experiment, is it staying in one dimension while the Earth turns? And then did it reappear somewhere else? Did it go into a time dilation dimension where it pulled out at a different time? Like you get a ghost ship where everybody's dead on it, and then it lands itself. You know what I mean? Like
okay. So if you want to give Philadelphia experiment credence, all right, and I'm just not going to have an opinion on that here. Okay, it would be a phase situation, right? So we're aware of that. Now, what does that mean? Well, that just means that your frequency band is coming out of tune with that of the ambient. Okay, so if you're dropping off of Planck scale, which happens in a cavitation event, right? Explosion, implosion to a single point shrinks to the point of falling off Planck scale. You were in the initial shrink event. Okay, this is what you're kind of dealing with. Now all of a sudden, your frequency band has changed outside of this, so you're still here as far as your perspective goes, but you're not relative necessarily to that which did not come with you. So it's weird because you would see yourself, because it brings you not into the fifth dimension, it brings you into the fourth, the threshold of the fourth, okay, which is kind of like a timeline situation. Now, if you were in the fifth dimension looking down, that's when you see the fourth dimension in action, which means that you see everything that has happened from here to there all at one time, and probably based on some kind of repeating schedule like we've discussed, right? But if you're on the threshold of the fourth dimension, all that means is that time and space had shrunk down to the point where see how this all ties right back? Time no longer experienced the same, because you're experiencing time dilation. There's a shrinking event, okay, that occurs. And when you're shrunken down at that point, you cross over this other side, the world kind of expands back to a certain degree. But you're in a totally different time circumstance where the relativistic nature of the third dimension that you're observing at that point, okay, seems like the ghost. That's sort of how it is. It's sort of like you still perceive yourself and everything that came with you as physicality, but everything outside of you then appears to be ghost world moving at a different rate, and appearing probably from a more observant point in space, meaning that like you are further away, so you can see more. Okay, but at the same time, you have the ability to kind of like focus into a point too. So depending on where that cumulative focus would be and where you're going to end up coming back into resonance, you would just phase back in, and then wherever you phase back in is based on that the resonance coming back into a normalized state. That's pretty much what it is. And I'm sure that there's some kind of cymatic multi-frequency beat, pattern with multiple offset beat frequencies that have to do with time and have to do with space. So depending on where you bring yourself back into pieces is, probably where you're going to end up back at. That's just kind of my idea about it. Like if you want to visualize it, because they always depicted it like, oh, well, you're in a void, right? Or something. And that's easy. That's easy. But it's more complicated than that because you are in the void, but at the same time, there's like ghost reality going on there, like that you'd be privy to as well.
So I don't want to say this. The cabin itself is pressurized, Joe. And if you have a battery in there, okay, it was an ion battery or whatever, is that what they're using? Those things right there catch fire very easily.
Yep.
So it's like a nuclear explosion where you're stuffing ions into the core of it in order to get a higher energy state. If you already have the pressurization going on in the cabin, then you create the energy. It's now localized to the core of the cabin, right? Therefore, you'd be having a RAV right in the center of that thing, and then it would create the fields on the outside. And then as the light reflects off of it, you can create orbs in the air immediately, and they would track right on the field lines of everything that goes on there in a rotational state, in the triangle state, which means the simple thing could have been as simple as this. That battery caught fire in a pressurized compartment, something that never really happens, but then you get a secondary effect because it had the right geometry in order to produce the field.
Yeah, I don't think that's how that went. I personally think that it's, probably laser, the lasers acting as carrier waves for specific frequency bands.
You think somebody did it then?
Yeah, you said, well, you can do it with lasers. It's not just lasers. The laser isn't actually what does it. It's like a component of the frequency band, but you have carrier waves like, could be X-rays, could be like, I don't know, could be a whole bunch of different frequency bands, frankly, that ride on the laser as scalar potentials. And then when you bang everything together, you get your deterministic conditions in an orb form, because that is the same as the orb form that Mike Faraday would see at that point, because it's directed energy, right? So you have that event that occurs. Now you have your orb form. It's sustained. All right. Once that's sustained and there's more than one, they become in relationship with each other. Then they start moving in the way that geometrically we know these things do to build their magnetism. Once the magnetism comes about, it's setting the field conditions in the entire area based on their own energy and their own motion. Okay. And then at that point in time, once they start to have a more dynamic, motion, those field vectors cross, the third occurs. That's when you get the expansion compression event that you always see. And the compression event in that case is the same as the pinch, but you're only seeing one side of the pinch. because the geometry of each sphere itself, okay, is already upper dimensional. So when you have something that is an upper dimensional geometry, that's then in relationship with other upper dimensional objects, creating new axes of motion, you're emulating upper dimensional geometries again in high energy states. That's what you're doing. You bring it high enough, you get your sweep event. Your sweep events when everything sucks in to a point, expands and contracts. That's it, man. It's what we've been talking about since day one, and that's what those orbs did, in my opinion. The battery situation, whether that's why they did it, I don't think the batteries had to do with the orbs at all. I don't think I think that the orbs could be made on demand.
Yeah, look, I don't disagree with it. I'm just trying to come up with alternative things until they figure out exactly what it is. You know what I mean?
Yeah, no, I get it. I mean, I got to be honest, and it's like I said, sometimes I knock Ashton Forbes, but truth is, and I've said it a million times, I actually really appreciate what he's doing, and I like the guy. I find the show entertaining. I have nothing against the guy at all. I do like to break chops because it's like, we did it, chat. You know what I mean? We did it. We figured it out. Except next week we'll have another episode and we'll talk about another concept and we'll do it again then. You know what I mean?
That is funny though, isn't it?
You get what I'm saying. Like, you got to keep it going, so it's just like whatever. Because
so he finishes it and says, "Yeah, we got it now," and then next week, he's got it now again, right?
That's it, right?
But we get it. Why? I mean,
and you know what? I would break the guy's chops and be like, "Well, we did it, chat. You've said you found it every single time, so what the fuck is it then? Because you've said it 1,200 different things." I usually disagree with that, except I know the one thing that most people miss, which is why I don't hate on him for it, because it's all the same.
Yeah.
It's all the same. It all works the same. It's all the same. So, people describe it 1,200 different ways. So we did it, chat, 1,200 different ways because guess what? We did.
It's the same way.
None of it's wrong because it's all the same.
I'm right there with you, Joe. I guess that's the thing. I want to shout out Jarvis real quick. Vortec, man. Thank you very much, brother.
Dude, really thank you. I'm starting to feel like a cheap stripper tonight. It's like, we're doing our show, and the next thing you know, a $5 ends up in the G string.
I guess I need to dance a little more. Huh. No, you know what? That's what gets me about his channel. It's like, I know he's got to see it. It's all the same, but he never says it. And I guess that's why every week it's, you know what I mean? We got it again. I guess that's why that he does it that way. And I never thought about it that way. I guess I should have connected the dots. But I'm always thinking, Ashton, it's all the same thing. We talked about the same thing last week as we talked about the week before.
Right. Different person, different name, different theory, same thing.
Yes. That's probably what it is. Yeah. That's funny. Now I get it. Now I'm in on it. Okay.
Yeah, right. That's why I don't hate on him for that, because I'd be, like, the reality of it is, it's like, how many times are you gonna figure it out and have the late breaking news that now we know what it is, and then point to a resource that gives a different explanation, because it's all the same. And that's that. At the end of the day, there's really, things boil down to the same exact repeating mechanism over and over and over and over again at every single scale. That's it. Like, and once you understand it on one scale, and it's actually not very difficult, it's like you just apply it and you're like, oh wow, that is how that works, isn't it? It's kind of cool stuff.
Okay, I'll take that in consideration next time I watch. Huh, very interesting.
Yeah.
Never really thought about it that way. I guess I should have, considering this is what we do all the time when we talk about it.
Oh, we don't even try to bring new concepts into it. We just literally talk about the same fucking thing every day.
How many times are you going to repeat it 100 different ways just to say the same thing? I mean,
well, but because it's fun because we apply it, right? So we're just applying it to all these different things, and we're like, and when you see this, this is how that goes, and when you see this is how that goes, and see how it's all the same. It's all the same. We could talk about the same thing without talking about the same thing for years because we could just apply it to all different things and be like, see,
oh yeah. We'll go into the different vocabularies of each end of physics, and then we'll just explain it in their vocabulary. Yeah, that's funny.
right on.
Because, dude, some of the stuff they win the Nobel Prize for, and you're sitting there looking at it, and I'm scratching my head, going, "Yeah, that's not quite right."
Here, I'll have a Forbes moment for a second. I'm the top physicist, and I should win the Nobel Prize. Here's my paper. Paper by Joseph Lowett on the theory of everything. It is all the same. give that man a Nobel Prize.
Oh, shout out Vortex, man! You put $2 more in Joe's G string. Congratulations! Thank you very much, Vortex. Seriously, thank you. Dude, that was worth the $2 right there, Joe.
Listen, I was.
You got your price of admission right there.
Yeah, you get to see the meat swing off it.
Oh, I absolutely love it, man. Oh, you did it again.
Listen, I ain't bending over, brother. Sorry, look. Listen.
Oh, that's too much.
My champagne rooms, those are 150.
Champagne room. Oh my god. Oh.
No, really, thank you so much, man. Very generous.
Yeah, thank you. I just love it that he hit you right there again with it.
Yeah.
Oh, there you go.
I put some pasties on for you. I don't know, man. Anyway.
Oh.
Right
he
on.
Did it again.
Listen. We're gonna have you on soon, man. I would say we shoot you an invite now, but we're deep into this one. I think we're a little too deep in today to, give you the time that you ought to have. So.
Oh, dude, cracks me up, brother. That's funny. Absolutely love it, man. You're awesome, Vortex, man. Jarvis out there. Oh man. Yeah, shout out Sean, man. I just came to my mind again, man. Sounds like they're killing it. I just got them schematics, by the way, from the devices I have that Lightspeed sent me. So I went through and just reverse wrote them, all the schematics for them and stuff. Went through everything, man, so that Sean has it. So we're going to start seeing Sean come up with the same program that I have. And he's going to start doing his testing with that around it.
Oh, yeah. Sean's results are going to be insane because of all the silly stuff that he does. It's like, I don't know where he comes up with it. I don't know how he thinks it up. I don't know. He sends me stuff and I'm like, oh, that's a glass ball. I'm like, oh, look, it's the sun inside of it. The entire thing. I'm like, oh, and look, it's a sun and it's arcing inside of the sun. I was like, yeah, this is weird. He's like, what do you think? Any ideas? I'm like, Sean, I have no fucking idea, brother. I'm like, yeah, tell me a little bit about it so I could like maybe play with the idea.
Oh. Here we go, Joe. Ulysses, give you 20, man. Right on, Ulysses. You're awesome, brother.
Yeah,
I love it.
I know that was the $20 for me to keep my clothes on. Yeah.
Save us all. Yeah.
Isn't that it? So I want to tell you guys a story real quick. So I have this all black chicken. Okay, and when I'm like talking Wesley fucking Snipes. Okay, like there ain't thing on him that ain't black. Beautiful, by the way. Anyway, so he runs around the backyard and he steals all the other chickens' worms and stuff that they find in the grass.
Oh, really?
Then he pecks them in the neck and runs away. And then and then when I approach him, because he's very, very friendly with me, he likes me a whole lot, right? I'm like, what did you do? And then he goes into his cage like he's in jail, right? And yeah, he's just like, he's like living the struggle. I'm like, bro, you don't gotta live the struggle. You have all the same worms, you lazy son of a bitch. You don't have to rob, you black ass chicken don't have to rob the fucking, the fucking other chickens for your worm. You could find it. There's a whole entire thing of treats and this and that and blah blah blah. It's like you live in a goddamn hotel mansion that was built for you. Like, can you just relax yourself? Sir. But yeah, that's my black chicken. And his name
That's
is Eclipse.
funny.
His name is Eclipse, okay, because he's a really cool kind of chicken. He's an I am Samani, right? And they're probably one of the rarest chickens there are, man, right? Well, anyway, they're all black, okay, and they consider anything that's not black on them to be basically a defect. Now, I guess he's a little defective, all right, because he does have right around like the feathers that go down, and you know how they go down on a chicken's neck like this, right? Hackle feathers or whatever. The very, very tips of them are like golden gold, like yellowish gold, right? So he's entirely black, and then these very tips and he looks like an eclipse, right? So if you look at him, his head is black, his body is black and iridescent, by the way. And then this ring around it is just like the rays of the sun. So I named him Eclipse. I thought that was cool.
Very cool.
Yeah.
He said his friend's got a big black rooster as well.
Yes. He's a big black cock. That's right.
BBC of the neighborhood.
Yeah.
Gotta have at least one.
He's thick.
He says it's magnetic. Oh, that's hilarious.
My goat Adam Sandler loves the big black cock. Adam Sandler loves the big black cock.
Oh my God, his goat's name's Adam Sandler. That's hilarious.
Yeah, man. You guys, you go to the Ragu Festival? The old man beats me with a hickory stick. Anyway.
You know, they wonder how Joe names everything out there. You know what I mean?
Oh, dude, we have like 30 chickens and they all have names, and I remember them. I have to remember them all because if not, then I'm irresponsible. Well, I had a rooster, Stinky, and I gave Stinky to my neighbor across the street. Stinky.
Oh no.
Yeah.
Oh wow. You know we've gone way past the thing now.
Yeah, when I start talking about my chickens and goats.
Huh. No. Not just talk about chickens and goats. Go way further than that. Oh wow. No, guys, this is so awesome. This is what I need. I'm having a bad day today. This is awesome. I love this.
Yeah, cheer you up a little bit.
Yeah.
Then you get to go on Traveling Fools a little later on. You get to do some Abby Normal.
Yeah.
I know that lifts your spirits, so.
Yeah, we talk about soccer tonight. That's not going to lift my spirits.
Oh, no. That's definitely not old man build style. That ain't my style either, though.
Oh, dude, you know what? I mean, I get it. It's a World Cup. Everybody's excited. And I think a lot of people that watch this show everywhere around the world loves the soccer.
Yeah, they love the soccer.
Yeah. Or real football. Yeah. I played as a kid with the AYSO, you know what I mean? Stuff like that. But I just never got into it as an adult.
No. Frankly, I mean, like, I used to watch sports generally when I was younger and stuff. Like, there came a point in my life where literally I couldn't give a shit less about how somebody else is doing that I have no say or impact on. Like, I'm like, I do not have time or one iota of fuck in my entire soul that gives a shit about this anymore. Like, I just don't. Like, you want to get upset because your fucking team won or lost, or they're not going to make it, or they're going to make it and they fucking blew it, or this guy's a fucking dickbag and this guy got caught, fucking drinking and driving, and it's like, you're like, oh man, my fucking season's over. It's like, oh, what does it matter? It doesn't. My team lost, so I'm gonna riot, flip cars, and burn a city down. Yeah, okay. Listen, you got the energy for that shit? I'd rather just be sitting on my couch.
I don't have energy for any of that. No.
Right. Oh my God. No care, no energy for that. I'd rather sit there and hack away at the side of a mountain looking for a fucking rock. Yeah. Legit. Legit.
So he says it's USA versus Aussies. Is that right?
Yeah. Well, that's crazy. Well, good luck to Australia over there. It's our 250th anniversary in this country, so just let us win. That'd be cool.
Yeah. Well, yeah. If the U.S. is still in it and they're doing well, then absolutely. I heard that they had a thing because the U.S. says it's more expensive, so all of the people that normally come over and watch it decided not to show up live because the U.S. was like 3 times the cost of everybody else in Europe. You know what I mean? You get the hotel room and the tickets and everything. It's ridiculous.
Yeah. That's crazy. Well, not to mention, when they have it in Europe and stuff like that, that's like you living in, New York, but being like, oh, damn, you know what? The World Cup's in Georgia. Oh, hell, I'll just go. You know what I mean?
Yeah.
And it sucks, but you do it, and you have a great time, and that's it. Like, coming from Europe to the United States, or Australia from the United States to the United States is a big deal. It's like a whole lot more involved.
If you're used to paying $300 a ticket, and then you turn around and come to the U.S. and they're $1,700 a ticket, the sticker shock's pretty bad.
Yeah. Sure.
I mean, that's just like way over the top.
Yeah.
So, I mean, people want to go there and have fun. That's the greatest part of soccer because the score doesn't go up very much, but they drink a lot of beer. You know what I mean? And they're always chanting their song for their team and everything. Dude, I love the crowd in it. It seems super exciting.
Yep. It sounds exciting. I agree.
So, yeah, that'd be a great tailgate party, wouldn't it? Don't they have tailgates in soccer? They have the same thing, right? Same thing as football?
I mean, I don't know if they tailgate over in Europe. They have little vehicles, not pickup trucks. Tailgate with what? Like,
I don't know, man.
A Mercedes or a Volkswagen? Like, I don't know.
Oh, they have, what are those other things? Range Rovers. So up in the back of a Range Rover. That might be all right.
It's very pretentious.
Well, I don't know that they all have Chevys and Fords, you know what I mean, to drop the gate and tear out the good stuff.
I'll tell you what, you can get yourself like a Ram over there or something like that. You're probably paying close to like $170,000, $200,000 for that thing, and
Oh, dude, you're paying $100,000 now for a truck.
Well, this is what I'm saying. I would say double the price. So you're probably paying about $200,000 for a Ram.
I was thinking about selling my truck, Joe, and I go, well, it's worth a lot more now than it was a year ago because people stopped buying the new trucks. Yeah. So they put a bunch of cameras in the truck so that they spy on you. They do a battery thing on your truck so that you have to go into a dealership and get your battery changed, which on a diesel, well, they would charge you about $1,000 for the 2 batteries to install them and clear the code on it. And if you try to change them yourself, you don't have the ability to change the code on it. And then they say that there's a right to fix out there, but these companies don't care. They don't follow those rules. They always find a way around it. And then all the vehicles out there suck. You can't work on them. They have to go to a dealership. They cost you $100,000 or more. And then you're calling a tow truck every time something happens instead of turning one wrench or one screw and being done with it. Dude, my truck, you just go out and buy batteries.
Well,
my truck is good service.
Screwed up, I mean, aside from COVID, because things never became normal after COVID and with vehicles, really.
Oh, yeah.
But really what screwed it up was, all those carbon emission mandates that they were trying to throw down. And then the EV push because what they ended up doing was taking every automaker, putting them in a direction that was dead on arrival, and you know, then retracted all of it, which is good.
Yeah.
But now, over that 4 years, 5 years while that was going on, it like just, that's a lot of R&D and money and development and stuff, and we're paying the price for all that now because now they're not going to be selling those cars and they're going to end up going back to what they were doing originally.
Yeah.
Look at Chrysler. Chrysler is crazy. First of all, how they're still in business, I have no fucking idea. I legit because they don't actually have any vehicles for sale. Like you could get a Chrysler minivan, you could get Rams and Jeeps. Okay, fine, that's a product line they still have, and they're recuperating right now. But like, think about Dodge. They sold Chargers and Challengers. They got rid of the Challenger, and then their Chargers they remodeled, didn't release right away, had delay after delay after delay, and then basically said, "Okay, so this is what's available now, but don't buy them because this you don't actually want this."
Yeah.
We're coming out with the better stuff soon now that these regulations rolled back, but we also detooled ourselves during that 4 year process because Stellantis sucks, and
Yeah.
yeah, and basically long and short, now they their Dodge line sells like a Durango, which has looked exactly the same for like 10 years. They have not made one change to that truck in 10 years. Okay, and a Hornet, which honestly I don't know who buys those because I've never really seen them.
Yeah.
I don't think anybody buys them. It's like for the sake of having a vehicle, in production. So but now they're coming back out with all the old stuff again, but it's taking a lot of time, but apparently they're trying to bring the cost down too. They're trying to say because they know that things got out of control.
Well, I don't think they're bringing the top price down at all, man. A lot of dealerships are hanging on to their inventory. Yeah. Well, I got the Cummins diesel in mine. I made sure when I bought it, I paid the extra money. So I got the sorry, give me a second. This takes care of something. I got the Cummins diesel because it's worth more in the end. So you could put 170,000 miles on it and you're just barely breaking it in, where other vehicles, you know what I mean? You put 140,000 on a gas motor and you're looking at the trash bin.
Yeah, it's true, and you're smart for getting that Cummins because, in all honesty, man, it's rough. Like Ford diesels, one's rough.
Yeah, it's pretty bad, man. Some of that stuff, I seen the shows on them, man. I don't know who this guy is, but he's not going to stick around at all.
Yeah. You're giving him the axe.
Yeah, he's gone, man. I'm just not going to play the game. And no care to do that. Yeah, we got a cool chat, man. I don't need it disturbed by some a-hole. So anyway, yeah, dude. I was looking at it, and I got a Dodge Ram, dude. It's a 4x4 long bed quad cab. It's a 2004 Cummins diesel, man. You put the chip in it, and you're going high output on it, man.
Oh, you
350 horses.
I don't know.
Yeah.
What did I think you had a Ford?
No.
Oh, you're a good man.
No. I got a Dodge, man. That Dodge, that's a monster engine, but the interior parts are kind of junk.
It depends on what year you got it. I mean, I had a 2019 Power Wagon that I bought brand new, 2500 with that had a 6.4 Hemi in it though. It was the only way it came at the time. I think they put Cummins in them now finally after 2 decades. But long and short, they redid the interiors on those things, and mine was totally, had everything, and it was absolutely phenomenal. Like really drop dead, and like fit and finish was really, really nice. Materials were pretty damn good. Seats were really, really nice. Things super comfortable. Had every amenity in it. But that was the 19. The 16 I had, was a 1500, and that thing was like a nice trim level and stuff. Leather seats, heated, whatever, like, and it was nice, but it was not nearly as nice. It still kind of had that like carryover, like Daimler Chrysler vibe to it, like where there's a lot of like clicky plastic and stuff, where it's like,
Mhm.
yeah,
Oh,
don't like that. But yeah, no, they did away with that shit a long time ago, and now they charge a lot more money for their trucks, and their trucks are absolutely gorgeous. And I mean, I drive a Chevy now. See, I'm a Mopar guy through and through. I got a frat sock on my thumb. I know,
nice.
it's like, but like I have no aversion to GM products. So like periodically throughout my life, I've owned Chryslers and Chevys and Cadillacs and this and that.
Well, I'll be honest with you. If you get an old vehicle, 70s, I'm buying Chevy. I'm not,
Mhm.
I mean, I understand the Hemi back then was awesome. If you got a CUDA, you might talk me into it faster than anything else. But other than that, man, I'm buying a Chevy. I don't fit in the Mustang. I tried to buy one time. My wife laughed at me. She goes, "You the fat guy in a little car." She goes, "It's not working for you."
Yeah,
So I'm used to the Chevelle, the Nova, you know what I mean, stuff like that.
I
So
hear that. I mean, I before I got this pickup, like I was in like a little interim place in my life, and one of the only carryovers that I had coming out of my divorce was my Dodge Daytona. So I had a 1990 Shelby Daytona, which
mm,
was a pretty kick-ass little ride, mint condition when I had it and everything. But like, I hate to say it, I daily drove that thing, winter, the whole 9 yards, you know,
yeah,
for with Coil proxies on it nonetheless, which is absurd. You're not really supposed to drive on those like less than like 60 degrees. Like but I drove that thing year round for like almost 3 years.
hmm,
Like all the time. And Turbo Dodge, man, that was a weird era for them. Because they made some really kick-ass cars, but like, where are they today? Like most of them, like they were just disposable.
yeah,
They by a 90 by like 98, 99, most of them were off the road.
yeah. No, that's kind of like what year was it? Um, yeah, you don't see a lot of Dodges trucks until they came out with a new body style that had the different hood. You know what I mean? They came in a little bit and then went up like that. All the other ones before that, I think I see one or two. You know what I mean? Driving around, and somebody has them in a mint condition state, but I don't see any other ones like that. But I'll see Fords out there all the time. The one where the grill comes in like this, it has one angle and then comes in another angle and then comes in. You know what I mean? And it's a
Mhm.
nice looking truck. Those ones I see a lot of. They have a lot of
Yeah,
Fords out there like that. That slope style, that junky slope style. No, those are all went to the trash bin.
yeah,
Um, yeah, and then Chevrolet, you get all kinds of old Chevys out there. People just no matter what will drive those things to the end of the earth. So, but
yeah,
I see
for sure.
very few Toyotas out there. The first, what they have, Titan or whatever they called it, the first ones of those trucks, those are all done. So Tundra, maybe it's what it's called. I don't know. Their first line of pickup trucks, those are all gone. There's no such thing as a Honda pickup truck out here in California. Those are gone.
Yeah, really.
Uh,
It's kind of
yeah,
surprising.
we get the Mercedes out here, those kind of things. When you get into the big cities, everybody and their mother's got some kind of junk like that or a Tesla. Like I want to say at least 30% of the cars out here are Tesla.
Hmm.
Like
Well,
it's really
that's
bad.
because California pressed it the hardest. They were like emissions
Yeah.
problem, tax, incentive for electric vehicles. Um, I mean, we've talked about it briefly before, but like just the whole irony of like environmental emissions and then realizing that lithium is a scarce resource that destroys entire environments. and leaches chemicals directly into, the entire environment, destroying the entire environment, destroying the earth, right? You what's happening up in the sky. It's happening right here on the surface when you lithium mine. Like,
Yeah.
a lithium mine can't be left and then developed again. That's it. Like, once a lithium mine, then a hole that was previously a lithium mine that you can do nothing with. So
Didn't know that.
yeah, well, a lot of these ceramic batteries and stuff, I isn't it funny how things go full circle? When we started 2 years ago, I was like, look, man, I'm telling you, dope ceramics, they're gonna do it. It's gonna be solid state dope ceramics, solid state dope ceramics.
Yeah,
Yeah.
they did it.
Now it's finally, then within months of me saying that, they were like, we finally have working prototypes on solid state dope ceramic batteries, that we're scaling for production. Cool. Okay. Now, next thing I think rumor has it that the next Samsung S27 Ultra will have some kind of ceramic ion battery. So now it's coming into scale production. It seems.
Didn't switch to a saltwater battery that they're coming up with now for like daily use?
I mean, there's a lot of different kind of battery technologies out there, man. But honestly, it's silly that these are the things that we reach for, because batteries are so fundamentally not difficult. I don't really understand. Like, the way that Mike approached it was was a very intelligent way. When Mike went out and did with his carbon and magnesium and all that makes sense. But that's still a cell. It's still a closed cell, and there's still liquid involved. These are all like, and I'm not knocking what he did, because that's fundamentally good because of what the high amperage it produces and for a very extended period of time, and that's wonderful. The whole point, though, being that if it's not a solid piece of material that just simply puts out and takes a charge, stores, puts out, takes a charge, right? Solid piece of material. You've just lost. Like, that's it. You need one set. That's the only way it's stable.
Yeah.
Either that, or you have something with liquid sloshing around in your phone, whether you realize it or not. So put a titanium frame around it and a piece of, corundum glass to protect it all, from blowing up.
Interesting.
Yeah.
Funny, it comes all down to the same thing, isn't it? Put things between the material, make sure you have a divider in it, and then make sure you compress it. And as soon as you do, miracles happen. You get everything you want.
Yep.
That's funny.
Energy exchange. Go figure.
Who knew? You know what I mean?
Changes chemically energy from this to that because of its molecular, makeup is switching ions. They attach the ions, and then you put the ions in, and then it's like, oh, you took my ions, and I need ions. Give me ions. Okay, well, here you go. And then just, like, that's how it works.
That's so funny because we always talk about that, don't we? Ancient Egypt, how do you get the stone to lift? Well, I don't know. Let's just go place some instruments out there, put them in resonance with each other, create the outside barrier walls, and then compress the ions in the core of it. And then what do we got? We got rocks that move quickly and with very little weight, even though they weigh a ton of what they are here, because they're taking the ion state itself and using the compression within it. It's so simple. And you look at it and you go, well, they told you everything already, didn't they? They had all the tuning forks there on their staffs. They had all the crystals on there, which were all vibrating at a different frequency. And they reinforced it. They were able to take the wire, and put it in between two tuning forks. And they knew that it would last longer and create the resonance that way. They did everything in there, and every chamber that they built and every geometry that they put in, they would tell you, hey, we're dealing with resonance here. It was like so in your face. And then you get somebody and you go, no, man, they push it on logs. You know what I mean?
It's all the same, bro. It's all the same. It's just like, you don't realize like what you're doing when you take an electrolytic acid okay, and then you put it between two different types of metal, okay, well, it starts dematerializing ever so slight amounts of each. And that dematerialization leads to free ionic charges that then go into a state of exchange with one another. And because they do this asymmetrically, there's always this gap of excess that occurs, right? So now you get to pull from one side. So you start to pull from one side. What ends up happening? Well, if you pull from one side, it pulls from the other. You pull from one side, it pulls from the other.
So funny, man.
I mean, it's pretty damn stupid, man. All you're doing is, and what happens when you break down the material into its smallest parts, it's able to reach a state of potential first, but then high excitation once it gets involved in this exchange thing, right? So it gets into high excitation as it exchanges, which also then gives it a vector direction. Like, you just got to understand that what happens chemically is simply physics.
Yeah.
That's it. It's all physics. Like, chemistry doesn't actually exist. Only physics.
That's so funny.
No.
Because once you realize what the ion does, it's pretty much simple throughout the entire process, right?
It's consistent throughout the process. The chemical reaction is actually a physics reaction that's occurring because of the energy exchanges that occur, right? And you have the chemical reaction because everything is trying to fall into the equilibrium states, neutralizing, right? So it breaks it down, then it breaks it down into what? And it's charged. Okay, it's got a charge bias. Now there's a motion, there's an exchange, there's current flow or current potential.
But that's why it's like I always look at the gold and they said, okay, we're going to get rid of the impurities. We're going to start adding acids to this thing. And then you see it all dissolve right in front of you, a solid matter object dissolve into a liquid. And you're going, okay, well, how are you going to get that back, genius, right? And then they go, oh, well, we're just going to use some more chemicals and we're going to get it into a solid state again. And I'm laughing because I'm sitting over here going transmutation that everybody freaks out about. If they're talking about the Russell scale on the periodic table, well, hello, they already figured it out. They just didn't put it together with the rest of physics. They said, oh, this is just purely chemical. We keep it over here where we're compartmentalized, so we won't add it to how things actually build out over here. You know what I mean? That's what I mean by compartmentalized. They don't understand that it's all the same thing. It's like somebody going, I'm going to debunk the electric universe, right? Why don't you write stupid on your forehead and then we'll all understand. Like, you're not debunking anything. You're an imbecile. You don't see it. You know what I mean? Oh, string theory doesn't work. Well, yeah, if things aren't in resonance, hey, guess what? We have no field boundaries. So guess what? Stupid again. You know what I mean? Mm-hmm. If you go, oh, well, then, traditional physics doesn't work. Well, they explained everything after it was done. So how can you get rid of that? We can see it's a true reaction. You know what I mean? After a reaction, look at it. So that's all in there. It's like,
I just think it's hilarious how they don't realize that matter is actually breaking down into something that is higher dimensional. And that's what I don't understand, and how heat is the signature. It's right there.
yes.
Like, when you look at what everything is doing, and then you realize the axes increase and the excitation level increases. You said yourself that existence, only pertains dimensionally relevant within the Planck scale. And when you push something over that limit or below that limit, okay, it falls off into a geometric dimensionally different thing, which makes it not here any longer. I don't understand how they can't make this connection, because it's clear as day and omnipresent. That's what's annoying.
There's a whole nother world out there, Joe, and it runs parallel to ours. It's in the UV spectrum, and we can't see it. It's right there. It's not like it's hard, because we know that the energy state's there. It's like, that's why I laugh when they create vacuums and they say, well, let's put it in a vacuum. Do you realize you just sucked everything special out of it?
See, ultraviolet is here. It's what's slightly beyond ultraviolet that's not. Okay. We can't see the UV. That's why it's ultra in the first place.
Right. But
It's
that's a
ultra
perception
because, right,
problem.
it's a perception problem for us. So it is here, okay, dimensionally relevant. But it when you start pressing at the high end of that spectrum, it will not be here for long. But then at that point, think about it. It just goes transient again. You get it? Because when you're talking about UV, now we're talking about light, and you want to call it photons. So let's call it that. So we have UV photons, okay, and that means that there's wave function at play. And when things go into that level of high excitation, it just falls back into a wave function again, into a state of potential until it collapses again. Like, fuck, man, come on. You know, Max Planck figured out the Planck scale, and then people accepted it as rule, and nobody wants to fucking follow it. Nobody wants to follow it. You don't want to
Oh,
realize
man.
that what is quantum has fallen off the Planck scale, and what is quantum is just another way of saying that it has become dimensionally superior because all lower dimensions are present in higher dimensions. Right? That's always been the point. That's why when you said earlier, well, when Philadelphia experiment happened, well, what do you think it was? Do you think it was a black void? I'm like, well, I mean, it was probably like a kind of void, but what did I just say? That's a higher dimension. You're in a higher dimension. All the lower dimensions are present. So what does that mean? That means that this is present too. But is it the same? No. Is it ghost-like? Probably. See what I mean?
Yeah. You know, with that Philadelphia experiment, Joe, I honestly think, can you jump forward and backwards in time? Yes. I seriously think you can. If you can understand energy states and you can understand pulling yourself out of an energy state into a different dimension and then reinserting the dimension, then it's really not that difficult to understand the concept, right? Because you're no longer part of the time dilation in that dimension. So now you can reverse it, go backwards, forwards, wherever you want to, and then reinsert yourself because you're not part of it at that point. I think that's what people miss. They think that, oh my God, you know, we got to reverse the world to get it. No, you got to understand what dimension you fall into when you start creating your own.
Weird stuff, Nathan. It's like the esoteric saying of, you know, the way out is from within. You know, that is it's so profound because it's so true, and it's exactly what I was saying earlier about constriction. Right? If you go within and within and within and within, you're constricting. Right? And when you reach that one point, that one single point, you've then crossed over into the greater thing, out of phase, expanse, much greater expanse. But from within, you have to constrict it down to a point to blip out. That's the deal.
But I think
And what does that say about MH370?
I could just be in another place in time.
The only way without is within. So when it goes within, well, then that's that.
Well, you never know, man. Some of these things could go slipping through the time and end up buried in a mountain. You just never know where you come back out. That's the hard thing.
Mm-hmm. Yeah. Don't move. We're in interspace.
Yeah.
You know, like
well, think about it, Joe. We all got there by creating the field bubble, the simple field bubble that mirrors the planet, right? That's how we started opening up all this strange can of worms, right? So when you start thinking about it, you go, oh my God, dude, all I have to do is start to create that and understand it properly. And now we can open a whole can of worms in physics. So we're no longer going back and recreating, you know, T.T. Brown's experiment. We're over here going, I'm making a field bubble.
The whole can of worms started where we were talking about earlier was when, at least in modern history, the whole can of worms started when we started fucking colliding particles. You know, we started colliding particles, and then they're like, oh, look, we split an atom, you know, and then they're like, cool, so that's possible. Now let's weaponize it and start the Manhattan Project.
Dude, isn't that
Like,
just such
and
stone age
at
shit?
the same exact time, UFOs started fucking like flying
Well, hold
all
on,
over.
Joe. It's stone age thinking, right? Hammer rock, hammer rock. You know what I mean? Or just smash them together. Yeah.
Little things, smash little things together.
It was like the simplest thing of understanding. Oh, we got to build a bigger one. We need a bigger hammer. Yeah, that's what we need. We don't want to understand the physics of it, actually how the thing's built out or anything. We just want to smash them together. I mean,
you know what we should do is we should shoot a foot around the fucking hadron collider, and then position fucking the guy who fucking decided this was a good idea, fucking nutsack, right there, and then just see what happens. You know?
kicking it as it goes by.
at this at 99.999% the speed of light.
Wonder what reaction that'll have. We're witness particles.
Wait, hold on. Could you imagine if that happened and they got stuck in a time loop? So it happened repeatedly over and over again, fucking indefinitely, and they couldn't get him out. It's like, well, he was just stuck getting kicked in the balls by a fucking speed of light foot.
Can you imagine that? You're stuck in a time loop, and that's all you do is laugh your ass off for eternity. And somebody's getting the balls kicked by it.
It's like, and then just some sadistic son of a bitch pauses the thing and then puts a fucking steel tip boot on the fucking foot.
Oh no.
Oh shit. But listen, I think it's just as good as an idea, like shooting two things you can't even see together, you know?
Yeah, might as well. At least we can see these and have some fun.
Yeah. Yo, somebody should ask AI to make like a like a fucking Python code for that, to like see what the physics of a foot kicking a testicle sack through the LRT would be.
I don't think it lots of place around.
Right, you'd see it break apart into trillions of pieces. The guy's fucking testicles, you know what I mean?
You'd have to get slow motion on his face the whole time. You know what I mean?
No, listen, he wouldn't even know what would happen. He wouldn't even know what happened. It would just disappear, you know what I mean?
Oh, that sucks.
Just fucking vaporize and be like, oh, hold on. What happened to my balls? And then it'd be like, hold on, let me pull the sensor data.
Oh my god.
It'd be like one of those things that they show where it's like zwip, 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 zwip. It'd be like...
He said, Joe said we finally found a use for the hydrogen collider. It's a transgender experiment. We're going to put your nuts in there and we're going to remove them real quick for you.
It's like, listen, guy who thought this was a good idea. Yes, it seems that your testicles were comprised of muons and bosons.
Couple of hairs on.
We found that the God particle was in your balls. Fuck that guy, man.
Oh, that's hilarious.
Fucking devil worshipping assholes. Some guy though, like he fucking shot himself in the head with like a fucking particle accelerator one time.
Did he really? What happened to him?
Like, yeah, and I think he like lived and everything. He was fine. Like he said that I think he saw some crazy shit though. Like
an acid experience?
No, I'm dead. I'm not even like being funny about it. Like, I mean, I guess it's funny, but it's not me being funny. Yeah.
Oh, dude. Okay, so we need to take the crazies, put them in the particle accelerator, and then switch their brains around. That's what you're saying.
Yeah, but that's like bigger than an MRI machine by like a lot. Like your local doctor's office isn't going to have one of these. Like, unless it's like, all right, we got to dig up the next 12 towns so we can treat the people that need lobotomies.
Well, today's there's a lot of those people out there. I'll tell you that right now.
Oh, you're not kidding. That's because they stopped doing it.
Oh my god.
Lots of people out there that need it because they stopped doing them. Yeah, that's how that goes. But they stopped putting people in nut houses too, which is crazy. Think about that shit.
Yeah. They should put whoever voted for it in their neighborhood. All the crazies.
Yeah.
That's the way it should work.
Well, I mean, the other thing about that too is like, even when you're crazy and medicated, right? Like, you know how many times they get people's medicine wrong before they ever get it right?
Oh,
And
yeah.
like, what? Wait a second. Hold on for a minute here. You mean to say that you need to try 27 times to get this person's medicine right? And the person that needed this like medicine because they were batshit crazy in the first place are going to have adverse effect 27 fucking times before you get it right, and you're going to space and you're going to space their appointments 6 months apart to give it time. hold the fuck on. I mean, that it can take like a decade and a half to figure you the fuck out. Meanwhile, you're just running about society. You know what I mean?
Yeah.
Holy shit.
They should have rubber roomed your ass and then stick them into you, see what happens.
Right. And then finally they get your ass square, but then all of a sudden you decide that you're normal because you've been taking your fucking medicine and that you don't need it anymore, and then you're just right back to square one. What the fuck kind of world do we live in? Oh my God.
Yeah, we're living in a bad one.
Oh,
in that instance,
bro.
yeah. As smart as we get, the dumber we get. I truly think it's a scale, Joe. Like, they got to get rid of something like it's pouring a water into a pitcher that's already full, and then some of it floods over. So we get a lot of the stupid ideas coming back again and again.
Whatever timeline we hit in 2012, man, it rid ourselves of common sense for the majority of human beings. Like,
yes, it did.
Like, it was like, oh, look, we're hitting the junction. This is the point where the timelines converge. Oh, look, we ended up on the timeline where we have no common sense. Wonderful.
Yes. We could be in Jetsons cars instead. We got a bunch of morons acting like The Walking Dead. That's what we got in return. Yeah, we're screwed.
Yeah, that's it. Well, all I got to say is, listen, we've been in Iran for like 4 months now. Just do me a favor. Get fucking done with that shit. Get the fuck out of there. And like, let's just stop playing games because now we've all seen it. Okay. We've all, like, anybody who's seen anything that's been going on in that war, we've all seen the fucking technology. You lied about what it was when you were showing it on the news, but we all saw it. Listen, you don't shoot green fucking laser beams down and then have all sorts of bullshit happen and then have things travel up the laser beam. That's not how that works. Just saying, there's things carrying on the laser beam that you're not mentioning. You're like, oh, how we have this laser fucking beam that's on the front of a destroyer ship. It's the size of the destroyer ship, pretty much.
Yeah.
And it's like, oh, rad, that's cool. And they're like, and here's how it works. We point this laser and it fucking melts the metal and shit. And well, then it fails. No, it doesn't. That's not how anything works. That's not how things work. That's not how things work.
But that's how they think it works. You
That's
know what I mean?
how they want. Yeah, they're telling fucking people, and people are like, yeah, they melt the fucking thing with the laser. I'm like, they don't melt the fucking thing with the laser. The laser's carrying the fucking signal, bro.
Yeah. Well,
the laser's carrying the signal.
They think of it in Star Wars or something, you know what I mean? Where they come out with this plasma and it hits something. That's what they're thinking. Let's just describe it like that so that people understand it. That's what they're doing.
Well, it's like, people, they've seen lasers light a match. Okay, let's just tell them that it like sets it on fire then.
That's the mentality of it, though. Whatever they can choke down and see that it's okay.
Right. Well, people can't look at laser beams, right? Well, get this. People can't look at laser beams or else they'll go blind and everybody's afraid to look at the fucking laser beam. Okay. So say it's a laser beam. So nobody will look at it. You know what I mean? Like, it's like fucking insanity. The psyop's deep, bro. Psyop's deep.
Oh, dude. Well, Joe, they got people believing in that crap. Okay. You don't know how many people go watch a Stephen Greer chat and go see exactly what they say in there. It's the same stuff.
So when they pointed the laser at a missile, we watched it together many times, you and I.
Mm-hmm.
They pointed a laser at a missile that was just getting launched. This thing has fucking fire blowing out of its ass. Okay, this missile. Then the laser comes on. Okay. and then the fire goes out and the missile disappears. Last I checked, when you shoot something that's filled with fucking rocket fuel and you're melting it and heating it up to the point where you're going to melt the material that it's made out of, okay, that's supposed to withstand hypersonic speeds, for Christ's sakes, okay, you're going to probably not put the engine that was previously burning out. I'm just saying. And then where did it go? I mean, it didn't blow up, that's for shit sure. There was no fucking explosion. It just simply disappeared. So where the fuck did the missile go? Well, it went in exactly the same place that MH370 went, at least for a brief moment. You know, and honestly, you know, like certain people better play nice, because, like, at the end of the day, if you can make them disappear and reappear, I mean, it'd be really funny if one of those just ended up in like the fucking Clintons, like upstate New York house or something. You know, it'd be funny as fuck. It'd be like, yo, enough of these guys. You know, fucking, they're fucking domestic terrorists. Get rid of that. It's just like they blasted out of existence. The next thing you know, it's in the Clintons.
It's like Will Ferrell's Land of the Lost. Remember that? Where they showed the pool in the middle of nowhere, and they're in the pool eating the big crab thing that came out of the ground, but around it you see all the things from the U.S. that showed up there in like one of those fields. That's what it's like.
Yeah, exactly, right. You know, it's crazy shit, man. They showed it too, and then they just lied about it. And it was like, people are like, yes, this was cool. Look, they burned up the rocket.
You watch it goes into another dimension, they're all pissed off at us. These pieces of shit keep putting trash in our dimension.
Well, isn't that what we said? Like, yo, that means we are present, okay? If it's a higher dimension, we are present within their dimension. We are a part of their dimension. We fucking open up this thing that sucks them into our dimension, and it's inside of a nuclear bomb, and they're like, fuck you. You know, like, you know?
They're all pissed off at that.
Right. And then, you know, and next thing you know, it's like they're like, all right, you know what? Maybe we'll try to blow them up like under the ocean or in the ocean. So this thing that's slightly out of phase with us doesn't get like sucked in and get fucking upset with us, because evidently dropping these things on land fucking irritates something that we don't know about, you know? And then they do that and they're like, yo, we're here too, bro. Like you guys just don't seem to get it. They're like, well, fuck it, just put it underneath the earth then. And then, you know, like, then they blow a manhole cover out into space. Then the UFOs start coming and they're like, final straw. Final straw.
Hey, you, instead of coming over here and start probing our asses, why don't you just tell us, hey, we're going to land on your lawn and tell you not to do the shit no more. You know what I mean?
Could you imagine, yo, if like abductions and cow mutilations were just a fucking spite job for us being a bunch of dickholes? They're like sadistic, you know, they're like, you know, really fuck with them. You know, if we like come and we fucking take them and pretend like we're doing fucking experiments on them, like we know everything we need to know about them. We're not fucking really experimenting on them, but like they have like this deep psychological fear of all this shit. So dude, it'll really fuck them up, and it's just like some spite revenge for us dropping nukes. Fucking up time space, open up a wormhole, sucking in the out of phase shit into phase inside of a goddamn nuclear blast, you know, all that sort of thing.
Oh man, that is funny. Yeah, the Greys came to fuck with us because we put a nuclear weapon in there and sucked them in. So they returned by probing our ass. Yeah.
Yeah, right. Mutilate
well, sense of humor on these little fuckers.
Them, abduct them. Yeah. You know, get the politicians in on it and be like, and you don't get to tell them, so they all think you're full of shit. Forever. They won't believe the damn thing you say, and it's like, you know what's funny is that being a patriotic American went from like the government says this must be good for us, right, to the government is full of shit, okay, and we know they are, and we're just going to nod. That's real patriotism these days. We're just gonna nod. Because we damn well know that there's nothing that we could 100% do, but you know, like you can't not acknowledge the fact that Right? We're here from the government. We're here to help. You know?
We're here to help. Yeah, we got your
we're here to
back.
help. Yeah. We're here to tell you the truth.
That ain't happening ever.
Listen, if they weren't lying and be like, we are the government and we are here to devalue your money.
Yeah.
You know, like for real. That seems to be the greatest truth.
Well, yeah, you're going to be stuck at the same shithole job for the rest of your life, and then you're going to die, and that's exactly the way they like it.
Yeah, even if, I mean, you know, the thing that tends to be hard is that, right, you could be like ever upward, right? You could be like, yo, I'm making more money. I'm breaking my ass now. I'm actually doing better than I was, you know? But then it's like, and the 15% better that I'm doing this year, and now everything costs me 15% more. I'm doing exactly the same. Son of a bitch. You know, it's like it's like objectively you're doing better. You're going through all the motions, doing everything you have to do, but yet the best you could hope for sometimes in some circumstances is just simply staying the same.
Yeah.
You know, but it shouldn't be that way. But here we are.
Yeah, that's why we had a middle class. Now we're all lower class, according to all the money statistics. You know what I mean? We like eliminated the middle one, so that we can never achieve the higher one.
Oh, but that was easy. All they had to do was raise the minimum wage.
Yeah.
Once you raise the minimum wage, then all the people that used to, you know, that couldn't afford things, that can now afford things. Now the price of what things cost goes up. So now they can no longer afford it still, but now nobody else can either. And then, you know, by narrowing the gap, you know, that much with people that were previously making double minimum wage, right? Now they're making the same as minimum wage, but that person didn't get increased. See what I mean? Ooh, that was the tough one. And if you were doing pretty good, like me, I mean, at one point in time in my career, like I was doing pretty good, you know? Well, okay, cool. But now everything costs more and I never got a bump.
Nope.
You know?
Well, that's what it is. It's the ultimate correction tool for getting rid of the middle class.
Yep. That's it.
Yeah. All right, Joe. It's been 3 hours, man. I think it's time about to call it.
Yeah, I think so, sir. Pretty.
Hold on, take a look at that real quick.
Yeah, why not? I don't think I ever showed you that one. I haven't been on mine in a couple of weeks. I've been a little busy.
Yeah. I'm making those chicken houses.
Yeah, making the chicken goat houses.
That's cool, Joe.
Yeah. Yeah, it's nice. I like those. I still like this one. This one's cool.
That's big.
Yeah. Yeah, it's big, but it's also a diamond shape. You know?
Nice.
Yeah. Anyway. Crystal show and tell for the day.
Right on. All right, here we go. I want to say thank you to Vortex, man. Came in hot with $3. I want to thank Darren. He came in with 5 man build membership. Vortex came back with 10, and then 5, and then because Joe was jiggling, he got another 5 in the G string, and then Joe started raking up deuces, man. He was getting the $2 bill.
Yeah, I like them $2 bills. Those are cool.
Oh, that's awesome. And Ulysses, man, thank you very much with the 20, man. Topped off Joe to keep his clothes back on. Thank you again.
Right on.
All right, guys. Thanks, you guys. Thank you to the chat, man. You guys have been awesome today. Thanks, Joe, man. It's been a fun conversation.
Peace and love, everybody. Have a good week.
Later.
The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.